Yes. Good morning, students. Today we will deal with the inorganic chapter, D and F block elements. Already we have seen complete detail with respect to D and F block elements. Today we would just summarize how the chapter goes, what are the important points to be remembered from the competitive point of view. All those things we will do by one. You should first understand one thing. D and F block elements is a chapter which is completely built on the fundamental of periodic properties chapter. Entire chapter deals with the physical as well as chemical properties of elements of both D block as well as F block elements. Physical properties, major physical properties. What are the major physical properties of an element? If I take an example, I can have atomic size. Size is a physical property. Ionization energy is very important physical property because ionization energy is the one which determines the reactivity of an element. Therefore, ionization energy comes. Then various oxidation state comes. Then we have chemical reactivity by considering the electrode potential. All these fits into a category called as my physical properties. Then taking electrode potential further in detail, how they react, how much electrons are transferred, all those I can fit into a chemical properties. Therefore, if you want to have crystal clear idea regarding the D and F block elements, fundamental of the fundamental periodic properties should be crystal clear for you. When it is crystal clear, only the physical properties. D and F is nothing, you will understand it very smoothly. Now, my suggestion for you students is very simple. You should know the elements of both D block as well as F block, along with the electronic configuration of the elements. However, I would have a short trick for that. We will discuss at the later point. When you know the elements and its electronic configuration, your 85% of the job is done. It becomes very easy just looking at the configuration. You will keep on solving any type of or any sort of question or any level of question that you will come across at any point of your competitive examination part. Therefore, first you should understand elements are important and its electronic configurations are important. Once it is done, our 75 to 80% of the job is done. Keeping this in mind, let us proceed now. Now, mainly we would deal with one is D block and one more is nothing but simply I can say it like F block elements. D block elements, as you know, is further divided into, I can simply write they are divided into 3D series. Further coming down the group they are 4D series. Then coming down I have my 5D series. Then coming down I have my 6D series. All these, each of the series will contain 10 elements each. Therefore, totally I have 40 elements in the D block elements. Going to my F block elements, just once revise, F block elements are of two types. The first classification I can make them as simply lanthanoids. There are 14 elements which would start from cerium and end at lutetium. Similarly, down the group, I have one more classification, that is nothing but I can say actinoids. In actinoids as well, similar to lanthanoids, crystal clear, there are 14 elements which would start from thorium and would end up at lawrencium. Therefore, here also I have 14 elements and here also I have 14 elements. 28 total contributes to my F block elements. Note a point, nowadays D block elements, majority of the questions are suppressed. Majority of the questions arises from lanthanoids and actinoids. Remember, any examination concentrates on where do you have exceptional case. General trend would be known by everyone, therefore questions have its own framework. What the competitive aims at is very simple, they would more concentrate on the exceptional part. Therefore, when you have an exceptional case, you should have a short note along with you, all the exceptional cases on your study table ready made. That would be sticked in your brain without any effort. When you have your exceptional case, D and F block elements becomes very simple. Now understand this one. D block elements having one generalized electronic configuration. Very simple. You know the story. In case of S block and P block elements, outermost orbital gets successively filled. S1 configuration turns into S2 configuration. Electron is added to outermost orbital. When you go to P block, same is the story. Totally 6 electrons are possible. P1 to P6. Each of the element successively placed will have the configuration something like P1, P2, P3, P4, P5, P6. Therefore, outermost orbital gets filled. In case of D block elements, we have a minute change. Rather than getting your outermost orbital filled, what gets filled is simple, it is the inner orbital. Therefore, inner orbital is usually represented by n minus 1. N stands for your principal quantum number, you know the story. Therefore, general configuration, just revise, it would come as n minus d 1 to 10, because in the D block elements I can have 1 electron to 10 electron. Totally I have 5 degenerate orbital, dxy, yz, xz, dx square minus y square and dz square. Each orbital can at the maximum occupy 2 electrons. Therefore, totally 10 orbitals is the one story. Second part is nothing but your outermost orbital, that is ns2. This is the general electronic configuration. To be precise, outermost electronic configuration of your D block elements. What is the story comes when I go into my F block? F block alli, you should look at the beauty. It's not n minus 1 d gets filled. Instead, the inner orbital to that will get filled. Therefore, I would say the outer electronic configuration or general electronic configuration for F block elements would something look like n minus 2f. How many electrons are possible in F orbital? I can have a minimum of 1. And at the maximum I can have 14. Therefore, I have the configuration like n minus 2 f1 to 14 electrons is possible. Immediately after that, I should fill n minus 1 d orbital. What is the n minus 1 d orbital? I know the story. Here I can have 1 to 10 electron is true. But knowing all the configuration, I am sure that I can at the maximum have only 1 electron in all the F block elements. You go to either lanthanoid series or you go to either actinoid series, story is the same. You do not have any other electronic configuration rather than your D1. D0 we want to consider, and other possibilities D1. And finally, you know the story, that should be ns2 electronic configuration. Therefore, this is the outermost electronic configuration of D block, that is of F block. Now, as I have earlier suggested, what you should concentrate? When a series is said, if it is 3D, you will know the elements like this. If it is 4D series, you will know the elements like this. If it is 5D, you know the elements like this. 6D elements is beyond the scope at the PU level. Reason being, most of the elements will not have a characteristic physical properties. Meaning is they have the physical properties true, but I cannot compare the physical properties with the earlier placed element. Reason being, some of them are synthesized, some of them are radioactive, all those stories would come into a frame. Therefore, the study becomes rather more complicated. Therefore, at the PU level, 6D series is not that much of prior important. Therefore, we would cover 3D, 4D, 5D as well as lanthanoids and actinoids. Once you understand this one, once you know the element, it becomes very simple. What is my 3D series? 3D series would start from scandium, then 3D series everyone knows because that has already been done in the first year. We know where the electronic configuration gets altered, all those stories. Let me once again put it: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These are the 10 elements. What is the atomic number? Atomic number would start from 21 and will end it at zinc, that is 30. Then actually from 31 to 36 I have my p block elements. If you remember the periodic table, it would be easier. 30 to 36 is p block elements. 37 and 38 goes to your f block elements, s block elements. Then I have my 4D series. Then I have my 5D series. Scandium, yttrium and lanthanum are the elements. Then titanium, zirconium and hafnium, vanadium, niobium and chromium, molybdenum and tungsten, manganese, technetium and rhenium, iron, ruthenium and osmium, cobalt, rhodium and iridium, nickel, palladium and platinum, copper, silver and gold, zinc, cadmium and mercury. These are the various elements of your 3D series, 4D series and 5D series. Understand this simple point. I have 3D series starting from my scandium 21 and will end at zinc 30. True. Points made clear. I have my 4D series 36, 37, 38 and this would start from 39 and would end at 48, that is for cadmium. 48 to 52 goes, 54 goes to your p block, 55, 57, 56 and 57 is your lanthanum. Lanthanum is 57, but as per the general trend you should have atomic number 58 over here, but that is not the case. Hafnium with 72. Therefore, what is the notable thing? Here totally I have 14 elements for which lanthanum is the prototype element, hence they are called as lanthanoids in general. Lanthanum notation is La. Lanthanum is a general notation used for all the 14 elements of your lanthanoids, that is nothing but Ln. Note the difference. Will start with the cerium with the atomic number 58, will end at lawrencium, lutetium with the atomic number 71. Then I have next my 6D series, for which I would say in between those now we will have all the actinoids. Actinoids are with the actinum is with an atomic number 89 and entire actinoids starts with the element thorium with the atomic number 90 and will end at lawrencium with the atomic number 103. Therefore, after that what I have over here is 6D series, if I commit, I have my rutherfordium with the atomic number 114 and will end at copernicium with the atomic number 112. 111 is one element that is called as rogetnon and this is the atomic number of this one. Going little more precise, all these are D block elements. If I want to compare the properties of anything, properties are never compared across the period. Remember this point. Properties are always compared down the group. Why the properties are always compared down the group? Point made clear. Upon construction of your periodic table, elements with common outer electronic configuration has been put group wise. Therefore, reactive would come as similar or somewhat similarities observed in the reactivity. Reason being, reactivity is directly proportional to, I can say either it is the ionization energy or it is the electron affinity. This is the story for the reactivity. Let it be ionization energy or let it be electron affinity. the electron which is involved is the outermost electron. Hence, usually what we would say is, when the outer electronic configuration looks somewhat identical or similar, their physical and chemical properties comes to be approximately similar is the story. Therefore, they are grouped like that. Therefore, my suggestion, you should remember the elements downwise. That is the best part of the story. However, you know 3D series you have already learnt, you learn it in that manner. 4D and 5D series you can learn in this manner. That is about my 3D, 4D, 5D and 6D series. Now, D block elements also has got one more name which says transitional elements. Why they are called as transitional elements? You should understand one thing. Transitional elements are those elements which would have the electronic configuration n-1d, 1 to 9 are nothing but transitional elements. When the d orbital is d10 configuration, I would have the box diagram representation something like this. When it is completely filled, totally 5 degenerate orbitals are there. When it is completely filled, there is no possibility of transition of electrons which contribute to any of the properties. Therefore, since here it is no transition, indirect meaning is I do not put them into transitional elements, even though they are D block elements. 2 points, simple. One is D block elements, one is transitional elements. D block elements or transitional elements will be true provided they have this n-d 1 to 9 configuration. If it is something like n-1 d10 configuration, their D block elements are true, but they are not transitional elements. Note this difference. Keeping this in mind, let me come to my previous one. Where do I expect my D10 configuration? I can expect the D10 configuration either at the copper family, otherwise on the zinc family. Actually, it is D9, but it will convert it into D10. You know the theory, exactly half filled, fully filled orbitals are found to be more stable, exchange energy comes into picture, therefore D9 gets converted into D10. Therefore, directly keeping in mind the previously said point, I can immediately say zinc, cadmium, mercury along with this one can also be included. They all have D10 configuration, hence their D block elements is true, but they are not transitional elements. Fine. You should get a doubt now. The doubt remains very simple. Sir, if that said point is true, then copper, silver, gold and this element being having D10 elements, whether they are classified as transitional elements. I would say they are not considered as they are considered as transitional elements. Why question will remain very simple answer. Answer says something like this. Any element I can put it into transitional case is true, provided they have n-1 d 1 to 9 configuration is also true, but it is true not only in the ground state, either in the ground state or in any of the common oxidation state. If they have my criteria n-1 d 1 to 9, then I can surely put them into a classification called transition elements. Therefore, point is clear. I can have copper, I can have silver, I can have gold and this element. Very simple. They are having D10 configuration. At their ground state is true, but at their common oxidation state, they will have the configuration something like n-1 d 1 to 9. That is the reason why we would call those elements as transitional elements. I think I made the point clear. Yes. Now, let me simply go to my lanthanoids series. If I go to my lanthanoid series, who is the prototype element? Lanthanum is the prototype element. Who is the prototype element for actinoids? Actinium is the prototype elements. He is with the 57 and he is with the 89. Then all the elements, totally you have 14 and 14 elements, would start at cerium with the atomic number 58 and would end at lutetium with the atomic number 71. And finally, I have here thorium with the atomic number 90 and lawrencium with the atomic number 103. Here totally I have 14 elements, and all those 14 elements here are called as lanthanoids, here are called as actinoids. What gets filled over here? Already said n minus 2 f orbital gets successively filled from 1 to 14 in both the case. Only principal quantum number will change. Therefore, keeping in mind, understand this one. Remembering the electronic configuration of all the elements is somewhat harder. We know the story. Therefore, what you can apply a logic is, I have a short trick for that. What is that short trick? You should remember the missing configuration in all the cases. Now, let me simply say, if it is a 3D series, scandium, titanium, vanadium, chromium, manganese, D4 configuration is not there. Instead, you have directly D5 configuration. Similarly, for the copper, imagine it should be D9S2. Instead, it would change into D10S1. D9 configuration is missing. Therefore, if you remember what is the missing configuration, electronic configurations of various elements could be easily deducible one. Nothing is tougher. Therefore, note down this one. I have 3D, I have 4D, I have 5D, I have 6D, as well as I have my lanthanoids, and as well as I have my actinoids. Remember, if this is the case, I have already told what is the missing configuration. Note down what is missing. Who is missing? Here I would say D4 and D9 are missing configuration. All remaining configurations will be intact. Meaning is simple. You would start from D1, D2, D3. D4 is missing. Therefore, you don't write D4. Directly write D5. Then it becomes once again D5. Then D6, D7, D8, D9 you are supposed to write it. But D9 you don't write it. Instead, you miss that and directly write D10 configuration. That is how it works. Therefore, missing configuration is D4 and D9. Here missing configuration is D3 and D9. Here you can say it is D8. Here you can say it is D9. These are simply missing configurations. Coming to lanthanoids, missing configuration is F2 and F8. Coming to actinoids, F1 is missing, F5 is missing, and F8 is missing. This should be F8. Therefore, how do you write the configuration of lanthanoids? You will write the F1 configuration is 2. F1. Next element you should write F2, but you don't write F2, you should skip F2. Then comes F3, F4, F5, F6, F7, F8. F8, should you write it or should you skip it? You should skip it because it is the missing. Instead of writing F8, you directly write F9, then you will go to F10. Here F1 is missing, apply the same logic, F5 is missing as well as F8 is missing. If you remember this missing configuration, when you solve questions, you can immediately write the elements, note down the missing configuration, you can deduce the electronic configurations very easily. That is how it works. I think with the electronic configuration, points are clear. Now, once you have understood the electronic configuration, what are the physical properties in this chapter we would concentrate upon is nothing but atomic or ionic size is of the most important one. Then what comes is nothing but your ionization energy. Then the third factor what we need to deal with respect to my oxidation states. Various oxidation states are possible. Immediately after the oxidation state, we would see about our chemical reactivity. Who contributes to my chemical reactivity? That point is nothing but I would say we would see in detail with respect to my electrode potential values. Electrode potential, I can have it like oxidation potential as well as reduction potential. Oxidation potential is not part of our study. We would more concentrate upon our reduction potential. Once this much part is done, we have few minute properties like magnetic property, why the color comes like that, all those stories. Fourth one, fifth one we can add it like magnetic properties. Sixth one we can say it like why D block ions are colored, more precisely in the aqueous solution they are colored, how it acts as ligand, all those stories will come. Then I can simply have something called interstitial compounds, all of them are already discussed, and one more point is nothing but I can simply like write it like alloy formation. These are the major physical properties we need to deal with. Going further, chemical properties ಅಲ್ಲಿ what comes to my head? Something comes to my head. I have two important compounds majorly has to be discussed. The first one is nothing but I can say K2Cr2O7, potassium dichromate, a powerful oxidizing agent. And one more powerful oxidizing agent is nothing but KMnO4, potassium dichromate. We have the titration of that. Theory part is also there, practical part is also there. Therefore, we would deal about dichromate in detail, its oxidizing behavior, how it oxidizes various species into its oxidized form, as well as KMnO4. These two has to be discussed in detail. We would take up one by one. We would summarize how the points has to be remembered. I would put it in a very little frame so that it becomes convenient for you people. Let me go to first my atomic size. Done. Note down these points, because look at the PYQs of your last 3 to 4 years. Whatever be the level of your examination, you concentrate on CET, you concentrate on NEET, you concentrate on JEE. What the format is, now they are making a transition in the format of the questions, they put it onto the question paper. What they do is, rather than you simply asking, they can give you simply like 4 elements and arrange them in the increasing order of size, decreasing order of size. They can give you ion, put it their ionization energy. Instead of putting this order type of questions, most of the questions are now being put it like assertion and reasoning type. Look at the last 2 years of format. It is very clear that how they frame the question is, they simply give you in a question 4 statements. Statement 1, statement 2, statement 3, statement 4. And options they would give you 4, obviously A, B, C, D. How they put it is, option A, 1, A, B is right, option 2, B, C is right, option C, C something is right, and none of this, all these format of questions. Reason because they want to evaluate you students more precisely. You cannot simply answer by something guessing. And how do they segregate the topper is very unique. They want to consume the time of the topper so that they can make sure that if the rank has come, he is really the able guy to get the score. Therefore, consumption of time is played nowadays. Putting it in the statement format, you will require most of the time to read the one. After the reading, you should remember what are the options you have, then you should be able to pick the right one. Therefore, sincere request, you understand this. Unless and until you don't know the reasons very crystal clear, it is impossible. Otherwise, it becomes very, very harder for you to crack any examinations. Therefore, what we would adopt in our teaching is also making the concept more and more clear, giving precise reasons for everything would lead you to a better result. Therefore, understand this one now. Let me go to my atomic size. If I go to my atomic size, just you go to your first year periodic properties chapter. I can write a general trend something like this. What I am going to discuss is nothing but I would say atomic size, or we are going to discuss about the ionic size. Understand? Atomic size, you know the story, it will decrease across the period, and atomic size will increase down the group. I would write one thing, understand this one, I would write it here as GT. What is GT? Is my general trend. General trend, atomic size decreases across the period, atomic size increases down the group. Agreed? Who are the factors determines this general trend? Otherwise, who are the factors which would determine the atomic size or ionic size of any element placed down the group or across the period? Who are they? The first point is, I can say addition of quantum level n. He decides. Yes, true. And second one is nothing but who decides is my Z effective decides. Effective nuclear charge. Alle I would write the formula as well. Z effective is nothing but Z actual minus sigma. What is sigma means? It is the shielding constant. Done. Third point is nothing but the same story comes. I can write it like shielding effect, otherwise I can call it as screening effect. Shielding or screening, both of them are different terminology used to represent the same thing. And the fourth point is you should understand, that is nothing but repulsion. Who is repelling? Repelling is electron is repelling one more electron in the same orbital. Electron is repelling electron in the same orbital, that will also decide the atomic or ionic size. Therefore, these are the four factors important. Assertion reasoning type they can give you by taking these factors. N, addition of quantum level. N, structure of atom you have studied. N stands for principal quantum level, addition of quantum level. Z effective, Z actual minus sigma. Shielding effect is how the inner orbital, illi bekidre I can put it like in the bracket, inner orbital. All the inner orbital electrons are responsible for shielding. They will act as a shield or screen between the nucleus and outermost electron. And the last one is nothing but your electron to electron repulsive force. These are the four factors responsible for determining the atomic size or ionic size. Done now? Understand this point. S block elements, P block elements is of one story. S block elements and P block elements are of one story. Usually the elements obeys general trend. Elements obeys general trend. I don't have much of the variations there. But remember, D block elements, they are risky elements. Why they are risky? They are all metals. Metals are highly reactive, low ionization energy, low electron affinity, low electronegativity. They are highly reactive elements. They fit into different crystal lattices like BCC. I have hexagonal packing, close packing, all those stories are there. They are dangerous. Remember, D block elements always has exceptional cases. You choose any of your physical properties. Let it be atomic size, ionization energy, electron gain enthalpy, electron affinity, standard electrode potential, whatever be the property you consider, they have exceptional cases is true. Hagidre, what is the conclusion we have? Conclusion we have is, what is that exceptional case? If you know what is the exceptional case, then half of your job is done. Said at the earlier beginning of this class, 75 to 80% is of exceptional cases. Have a hold on this exceptional case. What is the exceptional case? You should understand this one. To explain that, let me once again write the element: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Agreed? Go down the group: scandium, yttrium, lanthanum, zirconium, hafnium, yes, I would explain few things and I would have something like a pictorial method. You students, in order to remember, you should understand one point. Everything becomes it harder to fit into brain. True, we agree, we know the story. We have been seeing the students. What works is the different methodology how you remember the things. What I would do is, rather than remaining everything, I would have a image which is printed on my brain by looking at the same image for several times. I have this on my study table. Imagine the case, you have this image on your study table. Each day when you get up or when you fresh up, after getting the fresh up, when you leave for the school, you just remember this table has to be visualized one. Keep on visualizing for 1 week. On the 8th day, if you forget this, then you tell me. You will always remember the pictorial methods are the best method to get printed on the brain. Therefore, apply this logic. Actually, what is my general trend? I would simply write general trend. Across the period, it should decreases, and down the group, it should increase. This is the story. One is decrease and one more is increase. What is for D block elements? Let me tell you. When you go from scandium to chromium, the size will keep on decreasing. Up to there, the point is true. Up to here, the size will keep on decreasing. Then when I come to manganese, I have exactly D5 configuration. There is some extra stability is induced, and that extra stability causes its size to be increased a little more, very minute value. Values are in picometer. Therefore, when I go across here, chromium to manganese, actually there should be decrease in size as per general trend, but for the manganese, the size will slightly increase. Remember this point. Competitive concentrates here, not here. Concentrate here, not here, because he is the one with the exceptional case. Remember. Then after, look at the beauty. Applying my general trend, from iron to copper, there should be a decrease in size is true. Decrease in size is true as per my general trend. But for the D block element, where I should concentrate, my concentration should be on the exceptional case. And I would say iron, cobalt and nickel, copper, if I compare, I have approximately similar in their size. They are similar. If you look at the values, they vary by 1 or 2 units in the picometer scale. 10 to the power minus 2, it is getting varied, very small varies. Therefore, I can say size remains almost, we can put it like similar. Size remains similar there. What is the reason for the similarity in the size? That point you should understand. Similarity is caused because of this particular reason, electron to electron repulsion. Reason being, from there the electron gets start pairing up. When it gets start pairing up, electron to electron repulsion, which is a repulsive force, always causes the size to be increased. Actually size decreases, electron to electron contribution, repulsion factor contributes increase in the size, magnitude in decrease in size is equal to magnitude of increase in size. Then I can say both are opposite factors getting cancelled each other, therefore I can say size remains similar across there. Then when I go to zinc, once again I have D10 configuration, true, stable is true, stable ಆದ ಕೂಡಲೇ element the size will be definitely, it will little more increase, and I would say there is abrupt increase in the size for the zinc. That is the story with your atomic size. I think clear. Then coming over here, apply the same logic, copy paste. From here to here also size will remain same due to the same reason. Applying the same logic there, size will remain there also, story is the same. Therefore, can't you remember this pictorial method is the best method to remember. Now coming down the group, scandium to yttrium, there is regular increase in the size is true. But when I come from yttrium to lanthanum, size is increased. Illindellige once again size will increase, I would indicate it by I. But when I come over here, the size will almost remain similar. Even though zirconium and hafnium, niobium and tantalum would have approximately similar in size. Because of, what is the reason? Reason is because of my lanthanoid contraction. Note this point. Reasons are very important. Lanthanoid contraction causes similarity in size from zirconium to hafnium, and they are also called as simply chemical twins. Reason because having similar in size and togetherly occurring in nature calls them as chemical twins. Size similarity is the not only prime condition to determine the chemical twins. Make the point clear. In addition to similarity in the size, they should also occur together in the nature. Their ores should occur together in the nature. That is the story. Therefore, I think it is clear about my atomic size. Note this point. Once the atomic size you have understood, I think points are very clear for you. Then what was my second point? What was my second point? Physical properties. First one was atomic size, true. Second one is nothing but I can simply say it like ionization energy. Done na? If I want to concentrate on ionization energy, simple logic, understand, you first try to get the relationship between atomic size and ionization energy. Atomic size decreases, ionization energy increases. Atomic size increases, ionization energy decreases. Hagidre I can simply have a relation something like this. Ionization energy is inversely proportional to my atomic size. Once this relation you know it, concepts becomes simpler and simpler. Because what is the size variation? You have it over here. Once you know the size variation, they are inversely proportional to ionization energy is also true. Therefore, points are becoming more clearer and clearer. As the size decreases, ionization energy increases. Wherever you have, note down the values if required, wherever you have similarity in the atomic size will have similarity in the ionization energy also, because size is the predominant factor which determines the ionization energy. And when you have extra stable elements, something like I can write manganese, something like I can write zinc, when they have exceptional electronic configuration with the more stable, their ionization energy will always be more, i.e. is always be more. Remember, when I have exceptionally stable configuration, D5, D10, apply the same logic to your F block. What is the exactly half filled configuration? F7. What is completely filled for F block? It is F14. F7 and F14 elements should have exceptional high value for their ionization energy. D5, D10, F7 and F14. Same logic you go to P block. P3, nitrogen will have the higher ionization energy. P6, all your noble gases will have exceptionally high ionization energy. Reason because P3 is exactly half filled, P6 is exactly fully filled orbitals. Always will show exceptional high ionization energy values. Agreed? Remember one thing, ionization energy I can also relate it to reactivity. These are important factors. How they are related to reactivity? How well an element donates electron determines its stability. How well an element donate electron will decide its reactivity. Donation of electron and ionization energy, can I relate it? Lower the ionization energy, removal of electron is easier, or donation of electron is easier, therefore reactivity is higher. Lower the ionization energy, higher the reactivity, therefore I can say ionization energy and reactivity are also inversely proportional. Higher the ionization energy, usually lower is the reactivity, but I cannot generalize because there one more factor comes, electron affinity. Therefore, remember this, IE is inversely proportional to reactivity. Agreed? I can relate one more, note down, these are very important. How do you relate ionization energy and metallic property? Higher the ionization energy, non-metallic, lower the ionization energy, more metallic. Therefore, I can also relate something like metallic property to the ionization energy as well. Ionization energy decreases, metallic properties increases. Ionization energy increases, non-metallic properties increases. Those are the stories. That is with respect to my ionization energy. Get the size chart crystal clear. Ionization energy, very simple. Agreed? Let me do one thing. Now let me go to my, what was our this one discussion? Atomic size is done, ionization energy is done. Let me go to my oxidation state now. Oxidation state. Oxidation state is also very simple. The major point you should understand is this one. Number of oxidation states. Number of oxidation states will keep on increasing. They are nothing but, I would say, they are directly proportional to, this is the one, number of unpaired electrons. Number of oxidation states is directly proportional to number of unpaired electrons. As the number of unpaired electrons keeps on increasing, possible number of oxidation states keep on increasing. If the number of unpaired electron keeps on decreasing, possible number of oxidation state keeps on decreasing. They are directly proportional, unpaired electrons as well as your number of oxidation states. Therefore, if you know the configuration, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Number of unpaired electrons goes on increases up to the midway. Midway means up to the manganese. Up to manganese, number of unpaired electron goes on increasing. From there, what will start is nothing but, I can say, pairing of electron. Electrons, if it gets paired, unpaired electron gets decreased. Therefore, possible number of oxidation state, OS I would indicate, oxidation states, I would say number of oxidation state increases up to midway. Till whom? Till manganese. Thereafter it goes on decreases. Therefore, from here it goes on decreases. Zinc will exhibit only the oxidation state +2. Copper will have two oxidation state, one is +1 and +2. These are the only two possible oxidation state. +1 and +2 for copper and +2 for zinc. Remember, scandium exhibits only one oxidation state, that is +3. Having D1S2 configuration, +3 ಅಂತ ಹೇಳಿದ್ರೆ 3 electrons are lost. It goes into previous noble gas core. Therefore, I would say scandium exhibits only +3 oxidation state. Illinda illige, if you look at the table, number of oxidation state goes on increases. Thereafter, number of oxidation state goes on decreases. Therefore, in the picture you would have something like this. Idannu nenpittukolli, this image. This is nothing but exactly at D5. Up to here, number of oxidation state increases. Thereafter, number of oxidation state keeps on decreases. That is the story. Point made clear? Yes. That is about the oxidation states, possible oxidation states. Here, where does the question comes from? Either they should ask from the possible number of oxidation states. Otherwise, where the question concentrate, therefore your focus should be here. Focus here. Done now? More concentrate here. Now, oxidation state, when the concept comes, you should remember only 2 points. One is with respect to my unpaired electron. One more, I would choose my D block element, and one more for my comparison. And in order to make the concept clear for you guys, I would compare it with my P block elements. Let it be. One is D block and one more is P block elements. Let me compare it now. So simple. I have two standard statements. It would be like the Bhagavad Gita for us. Only those two statements would easily give you few marks. Then should you want to remember that or no? compulsory, mandatory, no choice. You should remember these two statements. What are those? What are those is very simple. I would write it over here. For the P block, down the group, stability of lower oxidation state increases. Stability of lower oxidation state increases down the group. That is for P block element. Whether here we are concentrating now? No. Where does our concentration comes? Answer. Our concentration comes over here because our focus is here. D block elements. Look at my D block elements. P block elements, as I said earlier, would obey general trend. D block will never. Hagidre adara ulta, this should be the case. What I should write over here? I should write down the group. You just control C, control V, but do the control V in the ulta manner. Down the group, what I should write it? Stability of lower, I would change it to higher, ulta of that one, lower, higher. Higher oxidation state increases. This is my Bhagavad Gita statement. Down the group, stability of higher oxidation state increases for D block elements. From here, question will come. Look at the PYQs. If you don't find these questions, then you tell me. Sure shot these questions might be there. Surely it is there. Concentrate. Down the group. Let me choose one family. If you have the electronic configuration, turn your pages and look at there. Can I say chromium, molybdenum and tungsten? Whether they belong into a same series? Answer is yes, sir. Chromium, molybdenum and tungsten, they belong to the same series. And what is the maximum oxidation state? If you ask me, here it is +6 is the maximum oxidation state possible for them. If it is +6 oxidation state, what does my statement says? What is the maximum oxidation state? I would say it as maximum oxidation state is +6. Whether their stability increases or decreases, as per the theory statement we have stability increases. Therefore, now you concentrate. I would put something over here. Let me write chromium at +6, molybdenum at +6 and tungsten at +6. Shall I say something like, if I put an arrow mark, stability increases. Stability increases anta helre, what about your reactivity? They are inversely proportional. I can say, therefore I can write reactivity decreases. Hagidre who is most reactive? Chromium is most reactive and tungsten is least reactive. One is most reactive, one is least reactive. Understand, who is most reactive? Avana compound should come as an oxidizing agent. Who is that oxidizing agent? That oxidizing agent is K2Cr2O7. Look at how you should relate the concept. Everything is there, crystal clear is clear, but you should be able to relate it. Here he is the least stable one is the most reactive one is the always reactive one. Therefore, K2 potassium dichromate is in our study. I can simply write, I can say K2W2O7, a better oxidizing agent, I can put it that. But among them, who is better? He is not, he is the best. Therefore, potassium dichromate is in our study. I think points are becoming more and more clear. That is with respect to my, nothing but simply saying, if I come over here, that much has to be concentrated over here. Oxidation state, what are the points you should remember from the competitive point of view? Is very simple. Stability of higher oxidation state increases, therefore reactivity decreases. Chromium being more reactive, potassium dichromate acts as a strongly oxidizing agent. This part. One more. Possible number of oxidation state goes on increasing up to midway, thereafter it decreases. 2 points more than enough. Done. Then we would see, come over this at the last part, I would finish this one, magnetic property, color and interstitial and alloy, all them are very, very simple stories we have. You know the case. For the magnetic property, For the magnetic property, what is the formula to determine the magnetic property? Square root of n into n plus 2 Bohr magneton. Very simple. Where n is, I can say, number of unpaired electrons. Number of unpaired electrons. More precisely, number of dl iruva unpaired electrons. SL is considered, but we will concentrate more upon D. Agreed? I can simply say scandium plus 3. Do I have magnetic moment? No, because n equal to 0. This type is already done. You just remember this formula, more than sufficient. After finishing magnetic property, interstitial compounds and alloy formation, there nothing has to be concentrated much. You should concentrate on few things. Let me tell you what is that. Interstitial compounds and this one. Let me finish my color. Now, very important. Looks like in the textbook you have around 2/3 of the page is with respect to your color of the ions. But ultimately there would be one question from the color is sure shot. Look at the PYQs of your JEE. Looks like a simple concept, but questions will always concentrate on either simple or the exceptional one. They won't make it so complicated. Color. Usually we will speak about color of ions. We would concentrate. Color of ions. Color of ions where we are discussing, because color of ions in the aqueous solution is the part of our study. Aqueous solution means, now to make it more clear, I would touch a little bit of my coordination compound and bring it over here. Understand this one. Aqueous means, shall I say the water is a solvent where you have the ions, then they will have a solution type. Agreed? Now understand this one. Whether H2S is a ligand, I can have strong field ligand, CFSE colliculation, all those stories are there. Keeping aside them, whether it is a ligand. Yes, sir. Therefore, how does the color appears is very simple. There are totally 5 degenerate orbitals in D. When you put it into aqueous solution, that being a potentially ligand, it should split. It should split octahedrally or tetrahedrally, depends upon the ligand. Water being more of an octahedral ligand, it would bring T to G and Eg, T to G to the downer and Eg to the higher. Done Allah. Therefore, I can simply write here T to G and I can simply write Eg over there. If I have a electron jumps from here to here, energy is absorbed. When they once again come back, energy is emitted. That would contribute to my color is the story. Adanne complementary color is seen anta heludu. Done. What is the short trick for that complementary color is very simple. You should write your VIBGYOR in this order. This is my VIBGYOR. Write VIBGYOR in this order. If the absorbed radiation is somewhat in the yellow and green, color seen to your naked eye will be exactly opposite color. That is how you identify. But nowadays those questions are not appearing. Illegal. Example, let me tell you. If blue was the absorbed color, what was the color seen? Color seen, I can put it like either red or orange or in between that. That is the shortcut to follow out. Clear? Therefore, you should be able to write the VIBGYOR in that format. You will get the answer. Nowadays, those type of questions are not coming. Done? No? Now, color is due to, understand the reason. What is the color? Color, when the question comes, you should concentrate on DD transition. Done? No? When the electrons is possibly can do DD transition, color is obviously seen. Leading me to arrive at a simple conclusion which says D0 configurations are colorless, because in order to have DD transition you should first have an electron. If you don't have an electron, how does the color appears? Point simple. Therefore, DD transition, no color, forget it, no color is possible. Next point is, can I say completely filled d orbital, D10 configuration? They are also colorless. D0 and D10 configuration. I can simply write a few example, scandium plus 3, titanium plus 4, and here I can have Zn plus 2. All these are simply colorless ions. They are all colorless ions. Scandium plus 3, titanium plus 4, zinc plus 2, all of them are colorless. Because this is D0, this is D10 configuration. Done now? What you can do is, we can do one thing. For our convenience, we construct a table. You construct a table, and what are all the possible colors? You list it out and you have it. I can have first part, I can put it like colorless. Here also one trick is there, how to remember. Color and how do you arrange is nothing but you remember this VibGR. As per this one, you keep on putting the colors. This could be correlated to your coordination chemistry as well. When we do coordination chemistry, once again we will rewind back and we will finish there. It is more convenient there. VibGR. Colorless is done. Then who comes? Then violet. In the aqueous solution, we don't have indigo. Hagagi indigo, you skip it. Then we have blue. Then what is the color? We have green. Then we have yellow. Then orange and red is not there. Instead of that orange red mix, I have something like purple. Then I have one more color is pink, and one more color is bluish pink. These are the various colors. I can list it out. Only these many colors are there. Who are not there? Indigo is not there, forget him. And last two are not them, forget him. Instead of orange and red, you put a purple there. Your story is done. Then pink and one more is bluish pink. As we have seen earlier, I can have a table, scandium plus 3, titanium plus 4, and as well as zinc plus 2 are colorless ions. Done now? In order to remember the table also, there are few things that you should understand. When the laboratory is done, when you come to the practicals, we would repeatedly tell, there is only one pink colored salt, that is manganese. Either who is in pink, immediately write down, it is Mn plus 2, ion is pink in color. Cobalt is very simple. Bluish pink are both the two cobalt, CO plus 2 and CO plus 3, both of them are bluish pink in color. Titanium's color is there given in the coordination chemistry chapter, that is titanium plus 3 is appears purple in color. Getting the point. Yellow, you have no confusion, Fe plus 3. Ferric hydroxide is yellowish in color, you look at that. Done now? Then you fill up this blue. Blue, don't you know copper sulfate solution is blue? Yes, therefore what is the ion that? Cu plus 2 is blue. Immediately you can write C in the start of one more element is Cr plus 2 is also blue, and addition to that vanadium plus 4 is also blue. Here I can have vanadium plus 2 is blue, immediately chromium plus 3 is blue, manganese plus 3 is blue. What is left over? Left over is here vanadium plus 3 as well as iron plus 2 and nickel plus 2. These are nothing but green in color. Note this table, and at any cost don't go to examination without remembering in this table. This would really give you one question right, mark my word. From here they would usually concentrate, more concentration they can give it over here, because this will appear in coordination chemistry as well. Done now? More priority is given over here, and remember these, I think you won't get a question because very simple. These questions are many of the times is already asked. They won't repeat it again and again, therefore forget this part. However comes you will answer, but to concentrate more on these parts. I think points are clear with respect to color. Agreed? Therefore I can simply say now, if I come back once again over here, magnetic property, what I should remember from the competitive point of view, n into n plus 2 root. Color of aqueous ion, what is the reason? DD transition immediately, then that table. These should go into your wall on your study table. Done, no? Then interstitial compounds, and one more is alloy formation. Very simple theories we have. Interstitial compounds have better properties, high melting point, they will retain their chemical reactivity. All those 4-5 points are there, you can make a note upon that, already discussed, very easier one. Alloy formation is also simple. Interstitial compounds, you should remember one term, that is voids, and small atom like hydrogen, carbon and nitrogen. And one point you should remember, interstitial compounds are nothing but non-stoichiometric. This term you remember. Stoichiometric means the ratio should be fixed. Non-stoichiometric means that ratio will not have a fixed behavior. Interstitial compounds are usually non-stoichiometric. Mark this, non-stoichiometric. Small atoms like carbon, hydrogen and nitrogen fit into the voids present in the crystal lattice. That is the meaning of interstitial compounds. Chemically, they are highly stable. Alloy formation is discussed, is more than enough, I think. Then we should move on to this part, chemical reactivity. Understand this one now. Here comes why I have kept my chemical reactivity to the final stage, because chemical reactivity in the I am going into my potassium dichromate and potassium permanganate. These are the two stories where I would try to go together. Agreed? Understand this one. Here in this chapter, see the case, chemical reactivity. From here I would go into a terminology called, you know it is nothing but electrode potential. Electrode potentially, more precisely I am going into a new term, is nothing but reduction potential. I am not at all bothered about my oxidation potential here. Reduction potential, in the keeping this in mind, I would go into my two important compounds, that is K2Cr2O7 and one more is KMnO4. These are the 2 points, K2Cr2O7 and KMnO4. I would touch these two topics. Higher the reduction potential, easier is the reducing property. Lower the reduction potential, lower is its reducing property. Higher the reduction potential, easier is the reduction, hence it will act as an oxidizing agent. Lower the reduction potential, lower is its reducing property, hence it won't act as an oxidizing agent, instead it will act as a reducing agent. Keeping these theories in count, we are going into my potassium dichromate and potassium permanganate. Now, in the reduction potential, you should understand one thing. Reduction, from where to where it is going to happen. I have two cases. One is I am reducing my M+2 ion into M. +2 ion is getting converted into my ground state. One more is I can concentrate like M+3 is getting converted into M+2. Agreed? These are the two types of categories I can make it. One is M+3 to M and one more is M+3 to M+2. If you have a thorough idea regarding your electronic configuration, this is nothing. Very easy. Nothing, very easy. Really. Now, I would simply write M+3 to +2, I am doing it. I would take an example like one. Zn+3 getting reduced to Zn+2. What is with respect to my question is E0 of reduction. What is my E0 of reduction is the question. High, low, or positive or negative, or more negative or more positive. These are the three different permutations possible. What is my E0 of reduction? You look at there. Zn3 plus is at D9 configuration. Zn plus 2 is at D10 configuration. D9 is more stable or D10 is more stable? Obvious, D10 is more stable. Hagidre, shall I write the conversion as it is getting converted from unstable to stable configuration? When unstable to stable, migration happens, do you think the reaction is easier or tougher? Reaction is obviously easier. Therefore, I would say E naught reduction will have high value, usually positive. If it was negative, it is more towards the positive scale. That is how you interpret. Zn plus 3 to Zn plus 2. Apply the logic over here. Can I simply compare my one more data, Fe plus 3 getting converted into Fe plus 2? What is my E naught of reduction? Tell me, what is Fe? Configuration of Fe is 3d6 4s2. Antellre Fe plus 3 will be at d5 configuration, Fe plus 2 will be at d6 configuration. Whether d5 is more stable or d6 is more stable? d5. Therefore, I would quote it over here, it is stable, here it is unstable. Look at now, from where to where you are moving? You are moving from stable to unstable. What should be the case? Whether the reaction is recommended or not recommended? Reaction is not recommended. Hagidre E naught of reduction will have high value or low value? Obviously, it should have a lower value. That is how you check it. Two examples I have taken it. Let them give you any example. Don't worry. Get to the electronic configuration first. Do this study. Do this study. Whether you are transiting from stable to unstable or unstable to stable. Unstable to stable, E naught of reduction is higher. Stable to unstable, E naught of reduction is lower. Higher and lower. Two cases done. Let them give you any configuration. Apply the same logic. Your answer would be true and right. Mn plus 2Mn. How to compare? You just take any example. Done? Let me do the conversion from manganese plus 2 to manganese. Agreed? What about this one? This is at D5 configuration. This is at D5S2 configuration. He is already stable. He is also stable. But stable to stable movement. He is already stable. Therefore, what do you do? E naught of reduction, you will say it like it will be lower. Here also you apply the same logic. Look at the stability value and apply the logic, you will get it right. Clear Allah? Let them give you anything. I can solve you one more. Shall we do it with any ion which says, shall we try to do it with the vanadium plus 2 to vanadium? Shall I try it? Agreed? One more, bed. Can I convert from vanadium plus 3 to vanadium plus 2? What is the configuration of vanadium actually? Vanadium is nothing but 3d3, 4s2 is the configuration. Plus 3 means what is the configuration? Vanadium at plus 3 will be D2. Reduce is happening to vanadium plus 2, whether it is D3. Yes, therefore write it over here. This is at D2 configuration, this is at D3 configuration. D2 configuration is not so stable, otherwise I would quote it as unstable. D3 is stable because this would have completely half filled, exactly half filled T2G3 configuration. Agreed? Therefore, he is unstable, he is stable. From where to where you are moving? Unstable to stable you are moving. Therefore, what should happen to my E naught of reduction? E naught of reduction should have a high value is true. Negative it should be more towards positive scale. That is how you determine your this one. This much point you keep in mind. Then one more point you should remember here is nothing but this important factor. Agreed? Understand this one. I can say reduction potential, otherwise oxidation potential. Therefore, better to quote it as nothing but I would say electrode potential. I can speak here both oxidation and reduction is nothing but equal to delta H of atomization plus delta H of ionization energy 1 plus delta H of ionization energy 2 plus delta H of hydration. This is how it works. This is a simple formula to have this. Understand, Out of this one are nothing but endothermic or positive, whereas your hydration is exothermic, otherwise I would quote it as negative. Done now? In this textbook you would see one point which says, if the hydration energy compensates this one, then we would have a positive reduction potential or negative reduction potential. That is how it works. And remember, in the reduction potential, it is the copper which has it like 0.34 volt, which is incapable of, remember this point, very very important, incapable of liberating H2 from acids. ಇದೆಲ್ಲಿಂದೆಲ್ಲಿಗೆ +2 to copper 0. Incapable of liberating H2 from acids, therefore they wouldn't be liberating hydrogen gas from water. This can also be related to your coordination chemistry, and discussion can be done, that we would take up when we deal with the coordination chemistry. However, it is possible. Here also I can discuss, there also I can discuss. For our convenience, we will put it there in the coordination chemistry. That makes better sense for us. Therefore, I think we have covered now all the points. Atomic, ionization, oxidation state, this part, chemical reactivity. Now we would move on to two individual compounds. Let me do it simultaneously. What are the things involved? You just see there. Very simple. The first compound is K2Cr2O7. The best summary short required I would discuss over here, and one more is KMnO4. One is K2Cr2O7 and one more is KMnO4. Here what is the things involved? Here I have preparation, here also I have the preparation. In both the cases we should see the preparation. Then we should see its reactivity property, otherwise oxidizing property. Preparation, from where you will prepare? Preparation involves, simply I can write 3 steps. That is how you should have a short note with you. Prepared from where it is prepared? Step 1, prepared from the chromite ore. Chromite ore is converted into, I can write sodium chromate. What is my second point? Sodium chromate got converted into sodium dichromate. Then what is my third step? Sodium dichromate is converted into potassium dichromate. You have the reactions, I have not written the reactions. Chromate ore to sodium chromate to sodium dichromate to potassium dichromate. How do you do the preparation over here? Same story. You will start up with your MnO2. MnO2 is converted into manganate ion. First conversion to manganate. Manganate is then converted into paramanganate. This is purple in color. Note down, this is purple in color. This is green in color. He is diamagnetic and he is paramagnetic. One is paramagnetic and one more is diamagnetic. This much point you should remember in the preparation part. Now going towards a little more into its oxidizing property. First part is preparation. Done of preparation, you remember this much value. Here also in the preparation you remember this one value. Next I would move to Next I would move to its oxidizing behavior. Oxidizing behavior. Here one is K2Cr2O7 and one more is KMnO4. K2Cr2O7 and KMnO4. Look at here now, very simple. Understand this reaction. Both of them acts as a very good oxidizing agent. Where means it is very simple, in acidic medium. Note down this point. In acidic medium they behave as a very good oxidizing agent. Acidic medium. In order to maintain the acidic medium, whom you will put? You should put sulfuric acid. Therefore, who is the reagent? Note down here. The reagent that you should remember is H2SO4 is put in order to maintain the acidic medium. Oxidizing behavior, acidic medium, H2SO4. Hagidre between whom and whom you should write the reaction. I would write it in this way, understand this one. K2Cr2O7 plus 4H2SO4 will give me the product K2SO4 plus Cr2SO4 thrice plus 4H2O plus 3 nascent oxygen. That is how I write the reaction. Done now? Look at him. Questions has come from this part. What is the color of chromium sulfate? Is green in color. Therefore, color changes from when you take potassium dichromate and H2SO4, potassium dichromate which is being orange in color will get converted into bluish to greenish shade, more probably greenish shade, due to the formation of chromium sulfate. That is the story. And see there, mark here, 3 nascent oxygens are liberated, hence they are called as oxidizing agents. Other, if I want to write the reaction over here, I would write 2KMnO4 plus 3H2SO4 will give me, what is the story? Same story, K2SO4 plus manganese sulfate 2 times plus 3H2O plus, note the difference, 5 times nascent oxygen. Look at here. What is the color of this manganese sulfate? Is colorless. Therefore, when you do the titration of KMnO4, end point is from where to where? Purple to colorless. Agreed? Colorless is formed due to the manganese sulfate. Look at here, I have a 5 nascent oxygens liberated. 5 nascent oxygen got liberated. 3 nascent oxygen got liberated. Who is better oxidizing? I would say one who liberates 5 nascent oxygen is better than one who liberates 3 nascent oxygen in the acidic medium. That is the reason this one. Additional point, very important, you should understand from where to where the transition is happening. Here chromium plus 6 gets converted into chromium plus 3. Here what is the story? I have Mn plus 7 getting converted into Mn plus 2. Totally how many electrons are involved? Very simple. Plus 6 to plus 3 is the migration. Therefore, total electrons involved is 3 electrons. Agreed? Look at here. Since there are 2 chromium, I would make them as 6 electrons. Here you see Mn to Mn plus 7. How many is involved? Totally 5 electrons are involved. I can similarly make it by having 10 electrons. When I write the half reaction, I can write it in 2 different ways. Therefore, I would keep it at 5 electrons rather than converting it into 10. Then what has to be remembered here? Therefore, equivalent weight is equal to molecular weight divided by number of electrons involved, 6. That would be nothing but 294 by 6. That is the equivalent weight, comes something around 49. Is the equivalent weight of dichromate. Come over here, what should be the story? Manganese, I should write equivalent weight of, this is nothing but my molecular weight divided by 5 electrons. do the math, you should get to something answer that is for you people to do it. Get to the molecular weight of potassium permanganate, then you divide it by 5, you will get to what is the equivalent weight of that one. I have done one thing, this is a homework for you, that should come around something around 31.6. That is with respect to oxidizing behavior. One is potassium dichromate and one more is potassium permanganate. If you remember this standard one, if you remember this standard equation, any of the thing that would require oxidation of any species will fall onto this category, will have the same logic over here, how it works. I think you are getting the point. I can oxidize iodide, I can oxidize ferrous, I can oxidize stannous, I can oxidize sulfide, I can oxidize nitrite to nitrate, sulfite to sulfate. Any of the species we can do it. All those theories have been already discussed. How it goes and what we can see it in the additional classes that we are getting. That is how it will work. I think the points are clear. You can take down these points. Then a few points are remaining. It would require additional of few time. One, we should go on to the lanthanoids and actinoid series. In the lanthanoids, very small topics are there. Few things should be covered. Most of the preciseness and most concentration should be applied to their chemical reactivity as well as electronic configuration. Questions comes from there, and then with respect to our actinoids we should see the case. That is with respect to my oxidizing behavior. Any of the thing I can keep it on oxidizing. I think we will continue it in the next class.
Once again, very good morning to all. So we are back once again with a new chapter under modern physics, that is atoms. Okay. We try to refresh few ideas what we have learnt. So today I am covering the synopsis of atoms chapter, and we try to solve few questions from this chapter only. Okay, first idea was given by Rutherford and Rutherford's alpha scattering experiment. He considered an alpha source. Alpha is nothing but 2 helium-4, passed it through the lead bricks. So the alpha beam was collimated. Then there exists a gold foil. When alpha particle collides with the gold foil, then the alpha scattering takes place. So the experimental observations are this: most of the alpha particles went without scattering. So amongst the few, one amongst the 1,000 was deflected back at 180 degree, is what the experimental observations we had from Rutherford's model. Then what about the plot of number of alpha particles scattered per angle of scattering? If I plot the graph, then I observe the nature of a graph something like this. Then what is the clarity we have? So almost 0, nearest to 0, for instance. Of course, this is 0, I know. I think I can even start from here also. So not touching to 0, which says that most of the alpha particles went, number of alpha particle is more with the scattering angle. This is for example 0.1 or 0.2, something like that. Most of the alpha particles went without scattering. Only few, say for example this is 180, if I generalize, then only few amongst the thousands of alpha particles, one amongst that will be deflected back. Then the atomic model has now got little significance. Why this alpha particle, as we have told, one amongst the 1,000 of the alpha particles was deflected back? Why? What may be the reason? Alpha particle is approaching the gold nucleus. So since the alpha particle nucleus also have, so the Rutherford stated the first statement that there exists a nucleus which has a positive charge. So in the atom there exists a nucleus has a positive charge. So what happens is, when an alpha particle approaches towards the nucleus of gold, then as you know, alpha particle nucleus also has a positive charge, and this force also have the positive charge. So it should have a repulsion, right? Because likely charges must be repelled. Then the alpha particle and so one of the alpha particle which is approaching the nucleus will be deflected back. Then there comes the concept called as distance of closest approach. Distance of closest approach. What is this distance of closest approach? Sorry. Minimum distance, an alpha particle, minimum distance between the alpha particle and the gold nucleus, I can say. That means, say for example, an alpha particle can reach to a distance of this. Then this distance from the nucleus of gold to the alpha particle, the minimum distance is called as distance of closest approach, we denote by R0. Then how can I note down the relation between the distance of closest approach? How can I arrive at the formula? Now then I can actually visualize, or I can use the law of conservation of energy. Now an alpha particle is approaching the nucleus. The moving alpha particle has the kinetic energy. By reaching to this distance, once it stops, right, because there exists a repulsive force, ಆ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ನ್ಯೂಕ್ಲಿಯಸ್ಸಿಗೂ ಆಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ಗೂ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಬರುವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ವಿಚ್ ವಿಲ್ ಬಿ ಕಮ್ಸ್ ಟು ಅರೆಸ್ಟ್. ದಟ್ ಮೀನ್ಸ್ ಕಂಪ್ಲೀಟ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್ ಆಫ್ ಕೈನೆಟಿಕ್ ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. Kinetic energy to potential energy. Then what is the kinetic energy I have? Half mv square. This is the velocity. V is the velocity of alpha particle and m is mass of the alpha particle, will be equal to potential energy 1 by 4 pi epsilon naught z into E and 2 into E, q1 q2. So z into E is a charge of respective nucleus, 2 into E is a charge of alpha particle, because alpha particle 2 helium 4 has 2 proton as well as 2 electrons. Then divided by r naught square. I am interested to note down r naught square or r naught, sorry, potential, that is why it is potential energy is just r naught. Then rearranging this for r naught, if I bring r naught to here, then r naught is z e square, 2 z e square into 4 pi epsilon naught half m v square. Move this to here. So 4 z e square divided by 4 pi epsilon naught m v square. I can cancel out this. So I can actually replace 1 by 4 pi epsilon naught, or even I can do, instead of cancelling out this, instead of cancelling 4, I can actually write 1 by 4 pi epsilon naught as k, 4k z e square divided by epsilon naught m v square. So I am getting distance of closest approach is inversely proportional to square of the velocity. So this is the aspect called as distance of closest approach. That means the minimum distance that an alpha particle between the alpha particle and the gold nucleus. Then, as we have told, most of the alpha particles are moving without scattering. That means almost most of the alpha particle will have a scattering angle of 0 degree. Then what is the concept called as impact parameter? Impact parameter. What is this impact parameter? So we have a gold nucleus, okay, nucleus of gold for example. Then impact parameter is nothing but the perpendicular distance. This is the perpendicular distance from the nucleus of a gold foil to the initial velocity of alpha particle. That means, see, initial velocity, alpha particle started from here, so initial velocity of alpha particle to the, or a perpendicular distance from the nucleus of a gold to the initial velocity of alpha particle is called as impact parameter. So based on this we decide whether the alpha particle will be move without scattering, or do we have a possibility of scattering angle and alpha this impact parameter theta is nothing but scattering angle. I can actually relate this scattering angle with the impact parameter b. Okay, what if b is 0, then what about the scattering angle? Think, if b is 0, that means if perpendicular distance, instead of the considering the perpendicular distance, if I had alpha particle somewhere here, then b is 0. Am I right? Are you getting the point? So if b is 0, then the what is the scattering angle? Now this alpha particle will have a collision, right? An inelastic collision, or no, there is no collision takes place, there is a repulsion. So then for sure which will be deflected back, right? So when b equal to 0, then theta equal to 180 degree. Then if b is maximum, that means if b perpendicular distance from the nucleus of, from the gold nucleus to the alpha particle is large, then I can say scattering angle is small. I think you are getting. So there is no scattering, undeviated movement of alpha particle can be seen. So this is about the idea of impact parameter. Then coming to the Bohr's idea, and what was the Bohr told that atom nucleus consists of positive charge and electrons are revolving in a non-radiate. Instead of saying, he says that electrons are revolving with the emitting energy. That means if I have a nucleus and electrons are revolving in the nucleus with the radiating energy, if they radiate the energy, then can it possible to fix the orbit? No. After some time it may go like this and finally falls to the nucleus. That's what the drawback we had. So he cannot explain the stability of an atom, and his model cannot explain about the spectrum or energy levels of the atoms, because that was the drawback what we had. That's why instead of moving to Rutherford's, to overcome the drawbacks what we had in Rutherford's model, now Bohr has introduced his new model of an atom, and which was most familiarly known as Bohr atomic model. What is Bohr atomic model? As we know, when according to Bohr's model, electrons are revolving around the nucleus in a circular orbit or in a stationary orbit. That means he fixed stationary orbit, and also called it as non-radiating energy, non-radiating orbit. That means energy cannot be emitted. Non-radiating energy, electrons are revolving in a non-radiating stationary orbit. That is the first postulate he had. Electrons are revolving around the nucleus in a stationary orbit or a non-radiating orbit. And then second one, as we already know, whenever I am speaking about the rotational motion or a circular motion, I should have the conservation of angular momentum, because the rotational motion, as we know, in a linear motion there is a conservation of linear momentum. In the same way, in a rotational motion there must be conservation of angular momentum. He stated that the angular momentum of revolving electron is integral multiple of h by 2 pi, where n is a principal quantum number, can take a value 1, 2, 3, etc. So angular momentum is the integral multiple of nh by 2 pi. So n is equal to 1 is the first orbit, 2 second, and 3 third orbit. In this way it goes. And then the third postulate he stated, when an electron makes a transition from, say an electron is excited to an excited state, let me take E2 and E1, then an electron can make a transition from higher energy level to a lower energy level by emitting a radiation of energy h nu, which is equal to the difference in the energy levels, difference in the energy of two consecutive levels. So an electron can make a transition from higher energy level to lower energy level by the emission of energy h nu is equal to difference between the two energy levels, E2 minus E1. So this is a few things about Bohr's model, and then by using Bohr's model we have derived an expression for radius of Bohr orbit, energy of Bohr orbit, or energy of, and before going to that aspect, I want to clarify one more thing here, that Bohr atomic model is applicable only for single electron system, single electron, that means or hydrogen like atoms. So I can clearly say Bohr atomic model is applicable only single electron system, hydrogen or hydrogen like atoms. This is about the Bohr model. And then the next aspect here I left is, I can actually relate the impact parameter to the scattering angle. Impact parameter is directly proportional to cot square theta by 2. So, this is one of the relation. Okay, I think we have done with the Bohr model. Then our interest is to account on radius of nth orbit. Radius of nth orbit of hydrogen. Rn is equal to n square h square by pi m ze square. N square h square epsilon naught pi m ze square. Anyhow, this expression is not much important. The only thing we have to remember is radius is directly proportional to n square by z, and I replace it by r naught or a naught, all the other quantities, where r naught is equal to 0.5 Fermi. So, having a clarity of that, 0.59 Armstrong. So, the only thing you have to remember is nth radius of nth orbit of hydrogen or hydrogen like atom is directly proportional to square of the principal quantum number and inversely proportional to atomic number n square by z. Then, how can I note down energy of nth orbit? That is minus 13.6 z square by n square. We are writing this in electron volt. So, I can say energy of nth orbit of hydrogen is inversely proportional to square of a principal quantum number minus 13.6 z square by n square, and I want to give a clarity why we have this minus sign. The negative sign indicates that, as we have already seen in a gravitation chapter, that negative sign one way specifies that which signifies the system is bounded. That means electrons are bounded to the nucleus. So, for all the bounded systems, total energy will be negative. Okay, then how can I relate the total energy to kinetic energy? Total energy equals to negative of kinetic energy, and then potential energy will be equal to negative of 2k. Then if I take the ratio of magnitude of kinetic energy to magnitude of potential energy, you are bringing this to here. So, I am speaking in terms of magnitude, that is why I can say magnitude of k by u will be equal to half. This is a common question asked in the exam as well. What about the ratios of kinetic energy to the potential energy, which is just a number half. And of course, from this you can even relate total energy and the potential energy. Total energy is u by 2, E equal to u by 2 from this. Everything we are writing is in electron volts. Then, in the same way as we have noted down the energy, there are so many other quantities which varies with the principal quantum number. So, we will list out all those things and we use that in solving the questions. All these derivations are not there in our syllabus, and we have to relate only the expressions. So, we are listing those things. Velocity of nth orbit is directly proportional to z by n, and then if velocity, then omega is nothing but angular velocity or angular speed, angular frequency which depends on z square by n cube, angular frequency. So, once I got angular frequency, for sure that is applicable even for frequency as well, 2 pi f, right. Then if frequency is known, can I write the time period, because 1 by f is time period. So, I can say time period is varies as n cube by z square, because the reciprocal of frequency is the time period. Then how angular momentum varies, already we have seen according to Bohr's model, angular momentum is directly proportional to integral multiple of h by 2 pi. So, angular momentum varies with the principal quantum number n as directly proportional to n. This is about the one thing. And then okay, here anyhow we have related the time. Can I write or how it relates to current? Current is anyhow q by t. So charge is need not to worry. I can say this varies inversely with n cube, because time period varies as n cube. So current varies as 1 by n cube. So this is about the few things. Okay, then we want to note down the energy levels. As he told, energies, each and every atom consists of so many energy levels. All these energy levels are discrete, not continuous. That means by this expression only we are getting. So for a hydrogen, if I write what I am actually getting, energy of nth orbit of hydrogen is minus 13.6 by n square. By putting the values of n, I can actually get the energies of individual energy levels. N is equal to 1 is known as ground state, n is equal to 2 is known as first excited state, second excited state. Like that it goes by increasing the values of n, because n varies as 1, 2, 3, 4, so on. Then okay, let me note down the energy levels of or discrete energy levels. Why don't we have a continuous? That means I have minus 13.6, after that do I have minus 13.5? No, I have something else. There is a missing of energies. We will be getting only few discrete set of energies. That means if I put n is equal to 1, known as ground state, the only base I have to consider here is En is equal to minus 13.6 n square. So if I put n is equal to 1, then I am having minus 13.6 electron volt. Answers are there in electron volt. Then moving to the next energy level, n is equal to 2, known as first excited state. By putting n is equal to 2, I have minus 13.6 divided by 4. So minus 3.4. So the first excited state has minus 3.4. Then second excited state, n is equal to 3. So putting n is equal to 3, I am having, so this is for the next one, and then minus 13.6 by 9. So 1.52 minus 1.52 electron volt. As it goes, if I go for n is equal to 4, minus 0.85. Am I going right? Yeah, 1.5 electron volt minus 0.85, minus 0.85, and minus n is equal to 5, minus 0.54 electron volt. So this are the set of discrete energies. N is equal to 1 ground, minus 13.6 electron volt, minus 3.4, minus 1.5, minus 0.85, minus 0.54. As it goes, do I have how many energy levels that an atom can comprises of nth kd, right? It can have, sorry, I just want to erase this. So L is proportional to n. Okay, I can go up to n is equal to infinity. What if I put n is equal to infinity here? Then I am getting energy equal to 0. So for it goes on up to infinity. When n becomes infinity, then the energy will be equal to 0, because something by infinity will be 0. So these are the discrete set of energies. By knowing these values, we can actually solve so many questions in the very easiest way. Okay, this is about the energy levels, and then the next thing we have to note down is about okay, when an electron makes a transition from this excitation energy, there are two aspects called as excitation energy and ionization energy. What is excitation energy? Energy required to jump or make an electrons to jump from the respective orbit to infinity is called excitation energy. So, how much energy you have to provide to make an electron to move to the excited state or to the state of infinity, that is called as excitation energy. And an ionization energy. What is ionization energy? Energy required to remove an electron from the atom is called as ionization energy. Okay. Then excitation energy is nothing but the difference between the two energy levels, that means E final minus E initial. That means if an electron makes a transition from n is equal to 2 to n is equal to 1, then that is the difference in the energy level minus 3.4 minus of minus 13.6 is nothing but 10.4 electron volt. So, the energy difference between the first two consecutive energy levels is 10.4 electron volt. What about for the next two minus 1.5 to minus of minus, that means plus 3.4. 3.4 minus 1.52 will be 1.9. So, in this way we calculate the values. Okay. This is about excitation energy. And then you have a relation or you have a quantity called as wave number. Okay, before that, how can I note down this energy, excitation energy, EF minus EI, that is 13.6. So, remember excitation energy is nothing but in positive of energy of nth level. So, 13.6 z square by n square. So, respective energy levels 1 by n1 square minus 1 by n2 square. So, this is hc by lambda, which is equal to 13.6 z square into 1 by n1 square minus 1 by n2 square. What is the quantity called as 1 by lambda known as? 1 by lambda is called as wave number. Wave number is 1 by r. Yeah, how can I note down that? As you know, 1 by lambda is r into 1 by n1 square minus 1 by n2 square. So, what is r here? R is known as Rydberg constant. Rydberg constant. Its value is 1.07 into 10 to the power 7. 0.021, or in general I can take 1 into 10 to the power 7 per meter is a Rydberg constant. 10 to the power 7 per meter is also fine. So, this is, and what is this R? R is Rydberg constant, and that we replaced frequency. Okay, we have noted down these things. Rydberg constant was done. Even I can write energy of nth orbit as we know energy is h nu is hc by lambda r into h into c into minus z square by n square. Here r into h into c is 13.6. That's what the meaning is. Then so these are the few related to energy levels and wave number, r into z square. Basically we have r into z square, r into z square anyhow for a hydrogen z is equal to 1. That's why we treat r into 1 by n1 square minus 1 by n2 square. Okay. Then we want to relate few more aspects. Okay, spectral lines. So, how many spectral lines we have in a hydrogen? Hydrogen, say for example, we have n is equal to 1, n is equal to 2, n is equal to 3. I write, better to write here, n is equal to 4 and n is equal to 5. N is equal to 1, n is equal to 2. Okay. When an electron makes a transition from higher energy level to the ground state, that means whatever the transition that will be to the ground state n is equal to 1, then a spectral lines we obtain is Lyman series. Lyman series which will be observed in the UV region of electromagnetic spectrum. Then where do I have the longest wavelength? I have longest wavelength for any of the series or any of the spectral lines, Lyman series or any of the series, longest wavelength associated with the transition between the consecutive levels. Okay. Then if an electron makes a transition from higher energy level to the respectively n is equal to 2 state, then the series what I am getting is Balmer series. Balmer series will be observed in the visible region of electromagnetic spectrum. Okay, if the transition is from n is equal to any n value to the n is equal to 3, then it is known as Paschen series. If the transition is, okay, we have few more energy levels here. We have to note down few. There are so many spectral lines series possible. If the transition is from higher energy level to n is equal to 4, higher energy level to n is equal to 4, then all those transition gives rise to a series called as bracket series. And if the transition is to n is equal to 5 energy level from a higher energy level, then we get P-fund series. So all these Paschen, bracket and P-fund series belongs to IR region of the electromagnetic spectrum. So these are about the spectral lines and spectral lines which are observed in a hydrogen or hydrogen like atoms. Okay. Then how can I note down the spectral limit? As we have told, I will be getting a longest wavelength when an electron makes a transition from consecutive. That means in the Lyman, if it is makes from n is equal to 2 to n is equal to 1, then I am getting longer. In a Balmer, I am getting a longest wavelength only when it makes a transition from n is equal to 3 to n is equal to 2. In a Paschen, I will get a maximum longest wavelength when it makes a transition from n is equal to 4 to n is equal to 3, and in a bracket it is from n is equal to 5 to n is equal to 4, and in a P-fund series from n is equal to 6 to n is equal to 5. So these are the spectral lines where we observe the longest. These are the energy levels to get a longest wavelength. Then last line of a series, or else we call it as a series limit. Last line of a series or series limit is when n2 is equal to infinity, n1 is equal to n, any respective energy level. n2, when an electron makes a transition from infinite energy level to the respective, based on the series. If I had it for n1 is 1, then Lyman, n1 is 2, Balmer, n1 is 3, Paschen, n1 is 4, bracket, and n1 is 5, P-fund. Infinity to n is equal to 1, then how can I note down the spectral minimum wavelength or a series limit? Then lambda minimum is just n square by r. Can you say how I got? 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square is what the formula we have. So n2 is infinity, so 1 by infinity is 0. I have just 1 by lambda is equal to r by, I just generalized, instead of taking n1 and n2 is not required for me, because by taking n2 equal to infinity I have equated to that to 0. So I can write n1 equal to n only. Then from this only, minimum wavelength is nothing but reciprocal of this n square by r. So very easily we can calculate the, so I can now say what is the limiting value or series limit of Lyman, series limits of Lyman series. What is the series limit of Lyman series? N is equal to 1, so 1 by r. What is the series limit for Balmer? Wavelength of minimum wavelength is n square, 2 square by r is nothing but 4 by r. What is the series limit for Paschen series? 9 by r. And for a bracket series 16 by r, and for a P fund series limit is 25 by r. So these are the series limits. Then if they have asked what is the ratios of wavelength of ratios of maximum wavelength to the minimum wavelength of respective series, what is the ratio of maximum wavelength to the minimum wavelength of Lyman series, then I can note down lambda max to lambda minimum equals to 2n plus 1 square by 2n plus 1 whole square. So this is how you can calculate lambda max to lambda minimum. So this is one of the formula we use. So respectively, if Lyman is n is equal to 1, then Balmer n is equal to 2, like that it goes. Then proceeding to the next aspect. So anything we left? No. Okay. Next, what is a condition for completely inelastic collision? Completely inelastic collision. Completely inelastic collision. So I just want to recall some aspects what we have learnt in the work energy power chapter when we are discussing about the inelastic collision. We have noted down that loss of kinetic energy is just half into m1 m2 by m1 plus m2 into u square. That means I can actually write half into m1 u square into m1 by m1 plus m2. Can I rearrange this to like this? I just considered what is this half m1 into u square, that is initial kinetic energy into m1 by m1 plus m2. So loss of kinetic energy is this. So to have a perfectly inelastic collision, this m2, sorry, this is m2 by m1 plus m2 must be greater than or equal to 10.2 electron volt. So this is about the condition for completely inelastic collision. Then I think we have almost covered. Okay, then we have one more, de Broglie's explanation for Bohr quantization condition. Bohr quantization condition is nothing but L is equal to NH by 2 pi. So integral quantized, like you know Q equal to plus or minus N into E. Quantized means number, NH by 2 pi, integral multiple of something. So he considered the path length must be n lambda 2 pi r, since electrons are revolving around the nucleus. Then I want to relate this nh by 2 pi. So lambda de Broglie wavelength, lambda is h by p. So I can write 2 pi r is equal to nh by p is m into v. Move this to here. So I have 2 pi r m into v equal to nh. So mvr if I keep here, which will be nh by 2 pi, which is nothing but, I specify mvr is nothing but L. So L is equal to nh by 2 pi. So by using de Broglie's idea of matter wave, even we can arrive at the Bohr quantization condition. So that's how it is arrived. So this is about the brief synopsis of the chapter atoms. I just go through my synopsis once. If I have left something, then we just refresh. Okay. So this is nh by 2 pi. Okay, fine. Okay, I left one thing, that is number of spectral lines. This is a most repeated variety of question. Number of spectral lines. N into n minus 1 by 2. So this is a most repeated variety of question. Number of spectral lines emitted is, how many spectral lines are emitted? That's the question you will be having generally. So that is n into n minus 1 by 2. So we'll solve the question. So based on that we can get a clarity of this. Okay, I just go through the synopsis once. So from the beginning only. Okay, we discussed about, I can actually say this distance of closest approach. Okay, as we are coming to the aspect of distance of closest approach. What is the distance of closest approach? Which is the minimum distance between the alpha particle, or minimum distance to which an alpha particle can travel. Minimum distance that an alpha particle can reach toward with the nucleus of gold. Gold nucleus sigu alpha particle ಎಷ್ಟು ಕ್ಲೋಸ್ ಹೋಗ್ಬೋದು, that distance is distance of closest approach. So what we have done, basically transformation of energy, kinetic energy to potential energy. So half mv square is equal to potential energy. Charge I have, so Z into E is a charge of the respective atom, and 2 into E is a charge of a alpha particle, that is helium. So from this I am getting some rearrangements I have done. Ultimately I got this R naught is inversely proportional to mv square. Then impact parameter is nothing but the perpendicular distance of initial velocity of alpha particle from the center of the nucleus. Then we calculate impact parameter will be 0, perpendicular distance will be 0 only when the particle will completely deflects back, then the scattering angle is 180 degree, b equal to 0, impact parameter. I can say impact parameter will be maximum. So when the alpha particles are away from this, then there is no repulsion experienced by the tiny nucleus. And if I ask what is the size of nucleus, size of a nucleus is 10 to the power minus 15 meter Fermi, and size of atom angstroms. So this is, and impact parameter is directly proportional to cot square theta by 2. And then going for Bohr model, there are so many limitations we had in Rutherford's model. Basically it cannot explain the stability, because as electron travel with the radiating energy finally falls to the nucleus, which is not possible. Then we need to know few more things, that electron is revolving. How can an electron can overcome the electrostatic force of attraction? So circular orbit alli hogta ide antandre centripetal force which balances the electrostatic force. So Bohr actually considered this. Centripetal force of revolving electron in a circular orbit will be equal to electrostatic force of attraction between the electron and the positively charged nucleus. Then Bohr model postulates, three postulates we have. One is about the, where I have in the next page, okay. One is about electrons are revolving around the nucleus in a stationary orbit. That orbit has a condition that which must be stationary as well as non-radiating, without radiating an energy. Electron is revolving without radiating the energy. And the second one is angular momentum of a particle is integral multiple of h by 2 pi, where n is integer, when n can take a value from 1 to 3. And the third postulate is an electron can make a transition from higher energy level to a lower energy level by emitting a radiation of energy h nu equals to difference in the energy levels. Okay, this is the characteristics, and then we are relating some aspects of Bohr model, applying the condition z is equal to 1. As I told, Bohr model is applicable only for hydrogen or hydrogen like atom. So radius of nth orbit, actual expression I have is n square h square epsilon naught pi m z d square, and I can say radius of nth orbit is n square by z and r naught is 0.5 angstrom. Or in general, I can actually need not to worry about this also, I can actually account only on this, which is directly proportional to n square, inversely proportional to z. And derivation is not required for the energy also, that is why we directly extracted the final expression what we have got in the expression, and we are getting minus 13.6 z square by n square, which will be there in electron volt. So if it is hydrogen, then putting z equal to 1, so you have minus 13.6 by n square electron volt. Then the total energy is related to kinetic energy as negative of kinetic energy. Why? As I already told, I should have total energy must be negative because it is a bounded system. Potential energy is twice that. Then if I write total energy in terms of potential, magnitude wise if I speak, then I can actually write U by 2. So if I take the ratio of kinetic energy to the potential energy, then I am getting a number half. Then velocity of nth orbit is z by n, angular velocity is z square by n cube, so that is the frequency as well. So time period is reciprocal of n cube by z square, current is 1 by n square because it is q by t, and angular momentum is directly proportional to integral or n, directly proportional to n. Then we are looking into the energy levels as he has told. Of course, we have a limitation also in a Bohr model, I just say that later. Let me go with this. It cannot explain the fine spectrum of atom. The statement itself we have is it is applicable only for hydrogen or hydrogen like atom. Those are some limitations also for the Bohr's model, but whatever may be, we have to note down the energies of respective. As we have told, the energies are discrete, not continuous. So I have a ground state which has an energy of minus 13.6 electron volt. First excited state has an energy of minus 3.4 electron volt. By just putting n is equal to 1, 2, 3 and so on, we are getting the respective energies: minus 3.4, minus 1.52, minus 0.85, minus 0.54, and as n is equal to infinity, energy will be 0. And excitation energy is nothing but energy required to make an electron to jump from the respective energy level to the infinity, so which is always positive. So then we have noted down what is the energy difference between the two energy levels. Energy difference n2 to n1 is 10.4 electron volt. In the same way, n2 to n3 is 1.9 electron volt. In this way it goes. And then going for the next spectral lines we have seen. So before that, we have noted down 13.6 z square by n square. So since I am accounting on two energy levels, so respectively I am considering the energy levels of n1 and n2. Then hc by lambda, that is 13.6 z square by 1 by n1 square minus 1 by n2 square. and 1 by lambda is nothing but wave number. Hc into r will be 13.6 antartha. So r is Rydberg constant, that is 1 into 10 to the power 7 per meter. Then once again we have noted down energy of nth orbit of hydrogen atom as r into h into c, and by writing this we can get r into h into c will be equal to 13.6 electron volt. Spectral lines, we have noted down Lyman, Balmer, Paschen bracket Fund series respectively. When an electron makes a transition from any energy level to n is equal to 1 Lyman, any energy level, higher energy level to n is equal to 2 is Balmer, higher energy level to n is equal to 3 is Paschen, higher energy level to n is equal to 4 bracket, higher energy level to n equal to 5 is P5. And in the same way, let the when can I get the longest wavelength in a transition? Only when it makes a transition from the consecutive higher energy level to the respective lower energy level. That means from n is equal to 2 to n is equal to 1, I will be getting longer. In a Balmer, I am getting longer wavelength for n is equal to 3 to n is equal to 2. If I ask for a Paschen, I can get the longest wavelength from n is equal to 4 to n is equal to 3. So in the same way, which region of the electromagnetic spectrum these spectral lines belongs, if I ask, then Lyman series belongs to UV region, Balmer's to the visible, Paschen and bracket and P-Fund series are belongs to the IR region of electromagnetic spectrum. Then what about the last line of a series, or which one is the last line or series limit? I can say the last line can be obtained, or a series limit can be obtained when an electron makes a transition from infinite energy level to the respective level. So respectively Lyman, and before noting down the Lyman and Balmer, we generalize, we can actually have 1 by lambda equal to r into 1 by n1 square minus 1 by n2 square, taking n2 equal to infinity. So we will be getting r by n square, so lambda equal to n square by r. From that I am simplifying. For a Lyman, n is equal to 1 because n1 is equal to 1. So 1 by r, Balmer is 4 by r, Paschen is 9 by r, and bracket is 16 by r, and P-Fund is 25 by r. And also we have noted down what is a ratio of maximum wavelength to the minimum wavelength, that is n plus 1 whole square by 2n plus 1 whole square. Then what is the condition for completely inelastic collision? From the inelastic collision aspect only, the loss of kinetic energy is accounted as half m1 m2 by m1 plus m2 into u square. We have considered there it as mu, but here I want to simplify. m1 into u square can be taken as initial kinetic energy, m2 by m1 plus m2. Then de Broglie's explanation for Bohr quantization condition, he considered the path difference equal to n lambda. Then equating, you are getting L equal to nh by 2 pi. So de Broglie's explanation was done. Then the number of spectral lines n into n minus 1 by 2. Okay. With having this detailed synopsis, we'll proceed to the some questions of this chapter. One second. How can I open this? Sorry for the inconvenience. We are continuing. We have few set of questions with us. We had a synopsis already. So going through the questions. First question I have is, an alpha particle, alpha nucleus of energy half mv square bombards a heavy nuclear target of charge Ze, then the distance of closest approach for the alpha nucleus will be proportional to. Okay, we have already have the formula for distance of closest approach, which is inversely proportional to mv square. So I can say 1 by m. Then number of spectral lines in the hydrogen atom is. Can I limit the number of spectral lines in a hydrogen atom? No. So there are infinite energy levels there in hydrogen atom. Then next, for the hydrogen atom, the energy of radiation emitted in the transition of fourth excited state to the second excited state. Okay, we have to solve this. Let me try. The ground state has minus 13.6, second excited state has minus 3 point, first excited state minus 3.4 electron volt, minus 1.5, then minus 0.85 electron volt. So when an electron or hydrogen atom energy is radiation emitted, transition from fourth excited state is minus 0.54 electron volt. That is n is equal to 5. Fourth excited state is n is 5 to n is equal to 2. Second excited state is n is equal to 3. So that means minus 0.54, am I right? Yeah. Minus 0.54 minus of minus plus 2, n is equal to 3 n is equal to 4 is here, n is equal to 3 is here. So, plus 1.5 electron volt will be how much? 0.54 minus 1.5, 0.567. This is the answer. Then moving to the next question. The ionization potential of hydrogen atom is minus 13.6 electron volt. Ionization potential, don't confuse or don't worry about ionization potential energy. An electron in the ground state absorbs a photon of energy 12.57. How many spectral lines can be expected when the electron makes a downward transition? Okay, we have given with the energy. In general, I know what is the expression for energy of nth orbit. Energy of nth orbit is minus 13.6 z square by n square. I want to find number of spectral lines emitted. I know the formula is n into n minus 1 by 2. So, how many spectral lines? To calculate that, I want to get what about n. How can I get the value of n? That I have to try. So, we have given with the excitation energy of or ionization energy of minus 13.6. So, energy of nth orbit is nothing but minus 13.6 plus 12.57. What about the difference? Minus 13.6 and to the 12.57, minus 13.6, 0.85, approximately minus 0.85 electron volt. As we have already seen here, minus 8.54 will be, okay, n is equal to 1 is a ground state, n is equal to 1 is for ground state, that is minus 13.6, n is equal to 2 is minus 3.4, n is equal to 3 is minus 1.5, n is equal to 4 is equal to minus 0.85. So, I get energy of nth orbit as 0.85. This specifies, this is a minus sign I am including, n will be equal to 4. Once n will be equals to 4, then I can calculate 4 into 4 minus 1 by 2 is nothing but 4 into 3 by 2. 12 by 2 will be 6. So, number of spectral lines emitted is 6. This is the fourth question. So, I think you got the point. Ionization potential, EV is electron volt, we generally writing. So, EV equal to some En which will be there in electron volt. So, potential is nothing but energy of nth orbit by E. So, this is also one of the clarity we can get. Okay, proceeding to the next one. The kinetic energy of an electron revolving around the nucleus will be kinetic energy of an electron revolving around the nucleus. How can I relate the kinetic energy in terms of potential levels? So, we have already written an expression in the synopsis. Potential energy is minus 2 by k, minus 2k, therefore kinetic energy will be U by 2. That means negative sign anyhow it is there, but if I consider the magnitude, then magnitude is nothing but magnitude of potential energy by 2 is half of the potential energy. Simple conceptualized. In a Bohr model of hydrogen atom, which of the following pairs of quantities are quantized? Of course, the second postulate in a Bohr model itself is a quantization of angular momentum, and energy is also quantized. So, both energy as well as angular momentum is quantized. Then The distance, seventh question, the distance of closest approach of an alpha particle fired at a nucleus with the kinetic energy k is r naught. The distance of closest approach when an alpha particle is fired at the same nucleus with the kinetic energy 2k. When I double the kinetic energy, how it varies? Distance of closest approach. They have told that distance of closest approach is nucleus with the kinetic energy k is r naught. While arriving the expression only, I have told the kinetic energy is perfectly transformed to the potential. So, kinetic energy related to the distance of closest approach as 1 by r naught. Am I right? So, if k is 1 by r naught, then if I make 2k is 1 by some r naught dash, then I can say r naught dash is equal to r naught dash is 1 by 2k. So, k is 1 by r naught. So, r naught dash is r naught by 2. Then next, the largest wavelength in the UV region of hydrogen spectrum is 122 nanometer. The smallest wavelength in the IR region of the hydrogen spectrum. So, they have not specified IR region, which specifically which spectral line is. They have not specified. IR region includes Paschen bracket and Pfund. So, I consider IR region the first one, and the IR region is Paschen series. For that, N1 will be equal to 3. Smallest wavelength N2 is equal to infinity. And in the UV region I have Lyman series, so N1 will be equal to 1. Since they have told the longest wavelength is possible when it makes a transition from a consecutive energy level. So, you want to find the wavelength, so 1 by lambda equal to r into 1 by n1 square. They have given you this lambda here, 1 by n1 square, 1 minus 1 by 2 square. So, 1 by 122 nanometer equals to r into 1 minus 1 by 4 is nothing but 3 by 4 r equal to 1 by 122. I simplify for r. So, I have 4 by 3 into 122 is equal to r. Let me keep r as it is. Now, I go for this smallest wavelength in the IR region. Smallest wavelength lambda, IR region, I am considering n1 square by r, smallest wavelength or series limit. N1 is 3, so 9 by r, that is 9 by r is 4 into 3 into 122. So, 2s are 61 into 27 or 61 into 3 into 9 if we do, then 183 into 9 am I doing right? So, 61 into 3 into 9 27 2 1648. Is it right? So, this is 4 by 3 into 122. So, r is 4 by 3 into 122. Substituting that, r is 4 by 3 into 122. Yeah, 1647. So, I think I am going right. Yeah. So, n square by r, about the answer we are getting. Fine. 122 nanometer, anyhow it is there in nanometer. So verify this, is it right? Okay. So I think D is the right answer. So everything is proper now. R is 3 by 4 into R, 1 by 122. 1 by 122 is 4 by 3 into 122. Then series limit is 9 by R, 3 into 122 by then next, which of the transition in hydrogen atom emits the lowest frequency? So we know the relation energy equal to h nu. So I can say frequency is lowest when energy is lowest. You have to verify which one will gives you lowest energy. I think you can try. N is equal to 2 to n is equal to 1 is 10.2, n is equal to 4 to n is equal to 3, n is equal to 4 to n is equal to 1. Energy is lowest. When energy is lowest, then the frequency is lowest. So energy is lowest possible for n is equal to 4 to n is equal to 3. N is equal to 4 is minus 13.6, minus 3.4, minus 1.5, minus 0.85, minus 0.52. So amongst this, if I make a transition from minus 0.85 plus 1.5, I am getting lowest energy. So that's why transition n is equal to 4 to n is equal to 3 is giving you the lowest frequency. Next, 10th one. According to the Bohr theory of hydrogen atom, the momentum of an electron. So we know what is moment of momentum. Moment of momentum is called as angular momentum, that I have told while in the first year as well. L is equal to r cross p, whatever the vector r we have, we treat it as moment of momentum. So r perpendicular distance is one way, call it as a momentum. So r cross p, moment of momentum of an electron in the second orbit of hydrogen atom. Second orbit means to say first orbit is n is equal to 1, second orbit is n is equal to 2. So n h by 2 pi. So this is the simplest one. So h by pi. N is equal to 2, 2 by 2 cancels out, h by pi. So this is the moment of momentum of hydrogen in the second orbit. Ionization energy of lithium 2 plus is equal to, so whatever may be ionization energy or something. So En is nothing but HCr, we have already told, minus 13.6. 13.6 is that, then Z square by N square. Lithium, so in terms, okay, sorry. HCr is, they have given you the answer in HCr. So HCr, hydrogen, helium, lithium. Lithium is 3. So 3 square is 80. So 4 by R. Wave number they have asked. Okay. This is wavelength. So 1 by lambda wave number mu bar is equal to R by 4. 1 by 4 is 0.25 R. 0.25. Last line then. Radius of an electron's second stationary orbit in a Bohr atom is R. Radius of third orbit will be, okay, radius is directly proportional to n square. They have relating only to the orbit, so I can say radius is proportional to n square. They have told that radius is r when for a second stationary orbit. What about for r dash? You have to say the answer in terms of r. So r dash must be equal to n square. Third stationary orbit is 3 square. So r dash by r will be proportional to 4 by 9. R dash is 9 by 4. 9 by 4, therefore R dash is equal to 9 by 4. So 2.25 times the R. So radius of the third orbit will be 2.25 times the R. So we have the synopsis with us, so which is easiest for us to move fast. Then the wavelength of the first line of Lyman series for a hydrogen atom equals to the second line of Balmer series of hydrogen like ion. Wavelength of the first line of Lyman series equals to the second line of Balmer series, then the atomic number. Okay. We first tried wave number 1 by lambda for a Lyman series. First line of Lyman series. First line of Lyman series I am getting when n1 is equal to 1 and n2 is equal to 2. That is the first line, right? So Rz square into Lyman of hydrogen. So 1 by n1 square minus 1 by n2 square. So putting z is equal to 1 for a hydrogen. So 1 by lambda is equal to R into 1 by 1 minus 1 by 2 square. So I am getting 3 by 4 times the R, 1 by lambda. So lambda is equal to 4 by 3 into R. So they have told the wavelength of first line of Lyman. Say I take first line of Lyman equals to the second line of Balmer series. So n is equal to n1 is 2 for a Balmer series. Second line n2 will be second line. First line is from 3 to 2. Second line is, okay, if I have this, n is equal to 2, n is equal to 3, n is equal to 4. So this is a first line and this is a second line of Balmer series, right? So when it makes a transition from 4 to 2, so n is equal to 4 is n2. 1 by lambda dash, that's what I have to, okay. Equals to lambda only, wavelengths are equal to R into z square what I have to find, equals to 1 by 2 minus 1 by 2 square minus 1 by 4 square. R into z square, 1 by 4 minus 1 by 16. Then 16 minus 4, R z square, 16 minus 4, 16 into 4. Further simplify this, 16 minus 4 is 12, R z square, 12 into 16 into 4. So this is 1 by lambda. Lambda will be equals to, that implies 16 into 4 divided by, or else I can even cancel 3. So 16, okay, (16) by 3 into Rz square. Then equating these two equations, equation 1 and 2, they have told first line of Lyman series equals to second line of Balmer series. Therefore 4 by 3 R is equal to 16 by 3 Rz square. So 3R cancels out. I am getting 4. Z square is equal to 4. So that's why Z is equal to 2. Which was the PYQ of NEET only. So atomic number Z is equal to 2. So that's how you can solve this question. I think that's clear. So atomic number Z of a hydrogen like ion is Z is equal to 2. Then I think you can go through this question once again. Then proceeding to the next question. We have to equate this because they have told equal first line of Lyman equals to the second line of Balmer's. So that's why equation must be written 1 by lambda equal to rz square. We have to include z square because sometimes they may ask something like this. At that time we should know what is z. Normally we remember the formula as r, as I, while doing the synopsis only I have written just r, which is a kind of muscle memory we have. So we simply put z is equal to 1. So better to remember z square, because in this kind of cases we should remember we have to put z square, then only we can able to find the z, or else it's difficult. Okay, then going for the 15th one. As an electron makes a transition from an excited state to the ground state of hydrogen like atom or ion, then what happens to that? Electron makes a transition from an excited state to a ground state. Kinetic energy, potential energy and total energy you have to relate. Electron makes a transition from excited state to a ground state. So I think this was a conceptual question. You can try this. I proceed to the next question. Anyhow, you have a relation with you. How can you relate that? You can try. It's the simplest one. Okay, then proceeding to the next one. Hydrogen atom is excited from ground state to another state with the principal quantum number equals to 4. Then the number of spectral lines. So this is also very simple. We have done the previous question only, maybe fourth one I think. There we have calculated n. By that we calculated the number of spectral lines. So this is very easiest. They have only specified n is equal to 4. N is equal to 4. So I can actually write n into n minus 1 by 2. So 4 into 3 by 2, 12 by 2 is 6. Then I think this is the easiest one. Next also, in which of the following systems will the radius of first orbit be minimum? Okay, right now here also I have to remember the z. Radius of nth orbit is directly proportional to n square by z. N square h square by pi m z t square is what the formula we had. So we have related in directly proportional to n square by z. They have told this must be a first orbit. So I need not to worry. N is anyhow 1. I want to worry only. I can have radius is depends. For this question I have to relate only this aspect. Radius is related, nth orbit is related, or the first orbit n is anyhow 1. So radius of first orbit is related to inversely proportional to atomic number. So look into the atomic number. Helium, singly ionized helium, doubly ionized helium, deuterium and hydrogen. Deuterium and hydrogen is anyhow Z is 1. So singly ionized and doubly ionized, here anyhow Z is equal to 1, because the deuterium and hydrogen are the isotope. Deuterium is isotope of that, right? So Z is equal to 1 amongst the singly ionized and doubly ionized. So singly ionized helium and doubly ionized helium will be having the minimum radius. Then out of the following, which one is not possible energy for a photon to be emitted? Photon to be emitted by the hydrogen atom according to Bohr atomic model. Out of the following, which is not possible energy for a proton to be emitted? So amongst this, which is not possible, I have 13.6. If an electron makes a transition from infinity to ground state, then difference in the energy is infinity to n is equal to 1. n is equal to 1. So then 13.6 is possible, because 0 minus of minus 13.6 plus 13.6, and already we have calculated, we have got 1.9 also when it makes a transition from n is equal to 2 to n is equal to 3. Look into the synopsis, and even we get make 0.65 also when it makes a transition from 0.65 to. So can I able to get 11.1, because minus 3.4 plus 13.6 never results in 11.1, so that's why option D is not possible. So the answer is 11.1 electron volt. Which amongst the following is not possible energy? So the synopsis helped us a lot to solve the question. Then Rutherford's scattering experiment, what will be the correct angle for alpha scattering for an impact parameter B equal to 0? So what is impact parameter? Impact parameter is the perpendicular distance of the initial velocity of alpha particle from the center of the nucleus. Impact parameter B is 0. As you know, already explained, I have a nucleus here. So when alpha particle approaches like this, then there is no B. I have a B here, but in this case I don't have B is 0, so deflects back. So scattering angle is 180 degree. Then ground state energy of hydrogen atom is minus 13.6 electron volt. What is the potential energy of electron in this state? We know the ground state energy is minus 13.6. How can I note down the potential energy? So I have related total energy equal to U by 2. So you can say 2 times the E. Potential energy. So 2 into 13.6 is minus 27.2. So is it right? U equal to 2 into E, I can relate, no? Yeah, because we know U equal to 2 minus 2k. So U equal to 2k magnitude wise if I speak, then k is kinetic energy. Kinetic energy is related to total energy. So 2E, that's why minus 27.2. Then the energy of hydrogen atom in its ground state is minus 13.6 electron volt. The energy level corresponding to the quantum number n is equal to 2 in the hydrogen atom is n is equal to 2. Ground state n is equal to 1 minus 13.6, n is equal to 2 is first excited state. Its energy we have already calculated, and that is minus 3.4 electron volt. Bohr's atom model assumes, okay, look into the options what we have. The nucleus is of infinite mass and is at rest. Yeah, he considered nucleus is of heavy size and which is there at rest. Electrons are revolving, so that is correct. Electron in a quantized orbit will not radiate energy. First postulate itself we have, it is a non-radiating orbit, so does not emit any radiation. Then mass of an electron remains constant, as we have told it is non-radiating, and mass remains constant. That's why all the 4 options are correct. So Bohr model assumes all the 4 options. So D, all the above is the answer. Then we will solve one question and we will wind up. Consider an electron in a hydrogen atom revolving in its second excited state of radius 4.65 angstrom. The de Broglie wavelength of this electron is. So Bohr's second quantization condition, second postulate was being explained by de Broglie. He considered the path length 2 pi r is equal to 2 pi r is equal to n lambda. By that you can actually solve. Okay, so 2 pi r is equal to n lambda. Second excited state. Second excited state is first excited state. Ground state n is equal to 1, n is equal to 2. First excited, second excited state n is equal to 2. So 2 into wavelength is 4.65 angstroms. 2 pi r, so I can cancel out 2 and radius of that orbit. de Broglie wavelength, oh sorry, somewhere I reversed. They have given you the radius, so we have to find the wavelength. I'm sorry. Okay, so 2 pi into r is 4.65 angstroms, n is 2, second excited state n is equal to 3, so 3 lambda. 2 by 3 into 3.14 into 4.65, so approximately 9.7 angstroms. So if I consider this as 3, then I can say lambda will be 9.7 angstroms. So we have done with the 23 questions. We have left with few more questions here. So we continue the discussion in the next class, and take a time, refresh the synopsis, and the remaining questions you can try to answer, or else we'll answer the remaining question in the next class. So thank you. Have a nice day.
Good afternoon, dear students. Hope you are all safe, happy at home, as well as your family members too. Maybe the climate conditions have stopped the temporary meeting us in the classrooms. Still, we are with you. Let us continue learning. In the last 2 sessions, we have studied indefinite integrals and we have solved around 60 questions from indefinite integrals. And right now, the last part of this chapter, that is definite integrals as well as its properties. So, I really miss you students inside the classroom. Without you, it is a lifeless classroom, I feel. So, hoping for your presence in the classroom at the earliest, let us begin the classes. So, definite integrals, you have studied, you know what it is, you have studied what it is, and let me take one example. See, I am considering integral of x square dx. This is indefinite integral. Now, let me give limits from 0 to 1, just simple example. So, what you have to do is only this much. You just integrate this function x square. So, you know it is x cube divided by 3, and now we will have to give limits to this. Lower limit is 0 and the upper limit is 1. And now you replace the variable by the upper limit. When you replace the variable x by the upper limit, this will be 1 by 2 minus, again replace the variable with the lower limit, it is 0. So, the answer will be 1 by 2. So, this is all about definite integral. So, here it is given to you, if the indefinite integral of the function f of x dx, if it is f of x plus c, then definite integral a to b f of x dx, it is f of b minus f of a. That is the integrated answer. You are first giving the upper limit minus then the lower limit. We have worked out exercise question, you are thorough in that. Just recall, that's all. And again, we have come across properties of definite integrals. So, we know the properties of definite integrals. See here, first property, it is rarely used. That is integral a to b f of x dx, it is equal to integral a to b f of t dt. That is change of the variable. Here variable x is changed to t, but change of variable does not change the value of the integral. That states the first one. And the second one, here they have changed, interchanged lower limit as well as upper limit. In the LHS, it is from a to b f of x dx, whereas here it is from b to a. As the limits are interchanged, what happens? The sign gets changed. So, the positive sign has changed to negative sign, that's all. Say if I do that, apply that to this problem. When I integrate it from 1 to 0, what happens? The answer x square dx. So, first what we have to do, give the value of x equal to 0, it is 0, minus give the value of x is equal to 1, it will be 1 by 2. To the first integral it was plus half. After interchanging the value of limits, the value of the integral has changed its sign, positive has become negative. That's all about the second property. And the third property, that is integral a to b f of x dx. Here there is a value, if there exists a value between a and b, let us consider it is c, then it can be split as a to c f of x dx plus c to b f of x dx. And that is more used in the case when the function is modulus function. So, for example, let me illustrate that with an example. Say here, if you are asked integral from 1 to 5, let the function for integration be modulus of x minus 2 dx. Say if this is the case, so this is the property helping you. That is, we will have to think when do this function become 0. We know that for x equal to 2, this is becoming 0. So what you can do is, you will have to break it like this. You are splitting it from 1 to 2, as well as the second integral will be from 2 to 5. Now you decide for the value x is equal to 1, that is this lower limit 1, let us evaluate the function inside the modulus function. 1 minus 2, is it not minus 1? That is a negative value. So we know by the definition of modulus function, we have used it a number of times. When you remove this modulus sign, what happens? There will be a negative sign fixed to it. So therefore it will be minus of x minus 2, which you can write it as 2 minus x dx. That is, a negative sign is fixed to the integrand inside the function inside the modulus sign. And to the values from 2 to 5, let us substitute x is equal to 5. Maybe any value, if I substitute x is equal to 2, it is 0, decision is not possible. Maybe you are giving any value from 2 and 5. So if I give the value of x is equal to 5, what happens? It will be equal to 3. So it is a positive value. So you remove the modulus, just write as it is x minus 2 dx. So I just wanted to illustrate how this property third is applied here. That's all. And then next, moving on to the next property, see, it is well known as King's property. So you know who a king is. So the reason it is called as king, see here, this is called as king's property, whereas this is called as queen's property. Some of the books mention it so. Competitive books mentions like that. Our NCERT doesn't mention so. So here it is widely used. A number of problems related to it. So it is the most helpful one. So its importance is that much. So for example, if you are with integral 0 to pi by 2 sine square x dx. So actual integration procedure is, you are substituting sine square x as 1 minus cos 2x divided by 2. In indefinite classes we have come across. Now does it help this property? It will help us answering it easily. So here what I can do is, I am just using queen here, queen's property. So integral 0 to a is pi by 2. Now I am going to replace the variable x by a minus x. So it will be pi by 2 minus x. And we know from our trigonometry that sin pi by 2 minus x will be cos x. So what happens? It will be changed to integral 0 to pi by 2. So sin square pi by 2 minus x will be cos square x dx. So if I have named it as I, and this 2 will be added. So adding the 2, you get 2i, and that 2i will have same integral with the lower limit and upper limit, and you know sin square x plus cos square x, it is equal to 1. So all that we have to integrate is 1 dx. So therefore I will be, integration of 1 dx will be x from where to where? From 0 to pi by 2. So the answer will be x, replace the upper limit by pi by 2 minus replace the variable by 0, the variable by upper limit. So you got 2i is equal to pi by 2, and hence I is equal to pi by 4. But to this kind of problems we can apply it still easier. We can remember that there is a shortcut method. The shortcut method is only so much, and the same thing is king also. Say if the integration is integral a to b, let us consider it like this: f of x divided by f of x plus f of a plus b minus x. If the question appear in this form, then whatever you have to do is apply this property, that is our king's property. Then what happens is, it simply reduces to upper limit minus lower limit divided by 2. Is it the same case here also? It is not exactly this form, but a part of it. So here the final answer is upper limit minus lower limit pi by 2 minus 0 divided by 2, it will be pi by 4. So easily you can get the answer. So it can be used where tan and cot functions come together, secant and cosecant functions come together, as well as sine and cosine functions comes together. So this is, we have a number of questions related to this. Let us come to it when discussing the problems. Okay, next is the other one, that is here. Yeah, integral 0 to a f of x dx, it is equal to 2 times integral 0 to a f of x dx if the function, in the function if you are replacing the variable x by upper limit minus x. So when you do so, if you actually get the original function itself, say if integration is from 0 to pi and it is a function of sine, you think maybe sine cube x or sine x dx, then what happens? We know sine of pi minus x will be sine x itself. So what happens? Sine cube of pi minus x will be once again sine cube x itself. So it satisfies this equation, that is variable is replaced by upper limit minus the variable, then it comes back to the original function. In such case, what happens? You can write the given integral like this, 2 times, here what you have to do, upper limit becomes half of the original value. So the integrand will be 2 times the integrand. That is a change happen. In case if that is equal to minus f of x, say for example if I am considering cos of x, integral 0 to pi cos x dx or cos cube x dx, you think what happens? It is cos of upper limit minus x. What is cos pi minus x? Minus cos x, we know it. So let us cube both sides. As it is cubing, negative sign remain. So is it not the function f of x, f of 2a minus x has become minus f of x? As it has become minus f of x, the integral answer will be directly equal to 0. So that is about the next 6th one, and it is used widely. More than that, here is the very important property. Maybe it is not named as king or queen. I think it is a minister or some important cabinet. So here it is from minus a to a f of x dx. That will be answer. See, remember when the lower limit and upper limit are opposite in sign, that is the important thing you will have to notice. Then obviously the question that to come to your mind is the integrand an odd function or an even function? If it is an odd function, it is very simple, just answer is 0. But in case if it is an even function, what happens? Here that changes to twice, but lower limit changes to 0. 0 to a, the function f of x dx. You have practiced a number of questions inside the classroom, but that was NCERT level questions. Let us think how the multiple choice question appear. And moreover, here let me consider some extra part, that is what to do when we come across the greatest integer function, or what to be done in some extra like some of the area, how to handle the questions. See, this is one of the shortcut method I have given you, make use of that. Okay, say for example you are handling a greatest integer function, maybe it is from 2 to 5, greatest integer of x dx. I am just illustrating greatest integer x, but its other type similar some applied questions will be there in the test paper. I will discuss it when it is time. So you know greatest integer function is periodic with 1 unit. So all that you have to do is only this much. You will have to split it into 1 unit each. So it will be 2 to 4. as well as next term integral will be from 4 to 5, as I have 2 to 3 and 3 to 4, as well as the last one 4 to 5. And now you know, for all the values lying between 2 and 3, what is greatest integer of that values? It will be just 2. We have studied that in our first year PUC. So here it will be 2 dx. How this function has changed. Then for values lying from 3 to 4, what about greatest integer of x? You know it is 3. So it is 3 dx, and obviously here it will be 4 dx. Then all thing is just integrating. So we can generalize it. The way we can generalize it is, here if it is integral 0 to NA f of x dx, where this function f of x is periodic for 0 to a, then it can be considered as n times integral 0 to a f of x dx. So that I will apply it when it is to be discussed. So keeping these many things in mind, let us try to work out the questions here. So here is the first question. So hope we recall the content of this chapter. Now let us work out these questions. So hope you all are safe, happy at home. So there may be distraction as you are not inside the classroom. Even if at home, be focused on the subject, because we have to study. You are to face the examination, right? You have to perform well in the competitive as well as board examination. Stay focused, and if whatever doubt you have, just contact me. I will be there to support you. So here integral 0 to 1 minus x by 1 factorial plus x cube by 2 factorial etc. up to infinity into e power 2x dx. So in limits chapter you might have come across, that is series expansion. What is the series expansion of e to the power of minus x? It is this, that is 1 minus x divided by 1 factorial plus x square divided by 2 factorial, negative, positive, continued. So we can replace the first function as e power minus x. So the question changes to integral 0 to 1 e to the power of minus x into e to the power of 2x dx. And we know when the base is same, we can simplify it like this. It is e to the power of 2x minus x, which is x dx. And we are with the answer. What is integral of e to the power of x? It is just e power x from 0 to 1. So it is e power 1 minus e power 0. What is the value of e power 0? It is 1. So the answer will be simply e minus 1, that is option B. All these questions are easy, basic questions. So let us learn that. And okay, here is the next question. So integration is from 0 to pi by 2 f of x, but they have defined the integrand f of x as an infinite series. Let us think, which series is it? The first term is cos x. How do we get the second term? By multiplying minus cos x to it. So therefore, is it not a geometric progression? Geometric progression added up to infinity. Let us go for S infinity of a GP. What is S infinity of a GP? A divided by 1 minus r. So A is the first term cos x divided by 1 minus r is the common ratio, and the common ratio here is minus cos x. So we need to integrate 0 to pi by 2 f of x. So let us integrate this integral 0 to pi by 2, this function. So here is integral 0 to pi by 2, so much dx. Then what shall we do? Will property work out or directly it is possible? We are one thing sure, when we come across 1 plus cos x, what can we do? 2 cos square x by 2. But here there is an extra function cos x. Substitution is also not working out. Let us add and subtract. That is the easy method. Add 1, subtract 1. So we can split into 2. The first function will be integral 0 to pi by 2. Cos x plus 1 divided by 1 plus cos x cancels and it will be equal to 1. And the next is 1 divided by minus 1 divided by 1 plus cos x dx. So where here we can integrate it. Here we have to make certain transformation. Let me write the part here. 1 plus cos x can be written as 2 cos square x by 2. So as it is 2 cos square x by 2. So what happens? I did not write the extra part, the starting part, that will be there. So minus 1 by 2 will be the constant. How do we write cos square x by 2, which can be written as secant square x by 2? We know the integral of secant square x by 2. What is the integral of secant square x by 2? So minus half is the constant in the second term. Secant square x by 2 on integration, it will be tan x by 2 divided by half. Here it is cancel. There was the first term 1. Integral of 1 dx will be x. From where to where it is? From 0 to pi by 2. Here let us substitute the upper limit. When it is given the upper limit, it will be pi by 2 minus, when x is given the value pi by 2 divided by 2, it will be pi by 4, and tan pi by 4 value is 1. So this is what I gave the upper limit, minus of, when you give the x value 0, the first term becomes 0, tan 0 is also 0, the two terms become 0. So it is pi by 2 minus 1. So is there an option with pi by 2 minus 1 as the answer? Yes, that is in option B. So here is B option, that is pi by 2 minus 1. Hope you are understanding this afternoon. Do you feel sleepy? No, it is not a theoretical subject. It is mathematics. You are working on that, is it not? So, yeah. So here is the next one. See, I shall explain this, and in the same way you should try with the next question. That is almost same. See, here we can find cot x raised to 4, whereas cot x to the power of 2. So what you need to do is, I am not writing the lower limit as well as upper limit because it is not board paper. We have to reach the answer at the earliest. So all that you have to do is take out the least degree of cot function outside. When I keep cot square x outside, what is left out inside the bracket? Here cot square x plus 1, and you know what is 1 plus cot square x, what is it? Cosecant square x. I am not again writing cot square x plus 1, it is cosecant square x dx. Is there any relationship between these two? Yeah, one function is the function, the other one is derivative. So we have to substitute cot x equal to t. So what happens? The first term become t square. And if cot x is equal to t, then what happens? Minus cosecant square x dx will be equal to dt. We are with cosecant square x dx, that is equal to minus dt. Now you need to find out the limit. When x attains the value pi by 4, what about t? Cot pi by 4 value is 1. When x is attaining its value pi by 2, t will be cot pi by 2. What is cot pi by 2? It will be 0. Reciprocal of tan pi by 2. So we have studied one property. Is it not interchanging the limit possible? When you interchange, what happens? Negative is going to be positive. Let us simultaneously integrate it. This will be t cube divided by 3. As I have changed the sign negative to positive, 0 becomes the lower limit and 1 will be the upper limit. So only thing is you will have to substitute it. On substituting you get 1 by 3 minus 0, and here is the option 1 by 3 is the right answer. So as I told that time, you will have to work out the next question, that is question number 4. So here is the question. What did I say then? Is there any comparison to the previous question and this question? So if you were here in the classroom, you will definitely shout with the answer, I am sure. So here is in plus in minus 2. What about in? Both these have the limit 0 to pi by 4. When it is n, it is tan x to the power of n, plus when n is replaced by n minus 2, it will be tan x raised to n minus 2 dx, that is all. Now there I told keep the least degree term outside. Here out of this, when n is positive, which will be the smallest degree, that is n minus 2. So when I keep 0 to pi by 4, tan x to the power of n minus 2 taken outside, what is left out here? There is tan square x plus 1. What is our tan square x plus 1? Nothing but secant square x. So we got the substitution. Substitution will be tan x equal to t. So the first term will be t to the power n minus 2, secant square x dx will be dt. Now you will have to decide the lower limit. We substituted tan x equal to t. When x is given the lower limit 0, tan 0 will be 0. When x is given the upper limit pi by 4, we know tan pi by 4 value is 1. So we just integrate it on using the formula. This will be t power n minus 1 divided by n minus 1 from 0 to 1. On substituting, replacing t by the upper limit, it will be 1 by n minus 1 minus, give t equal to 0, the term becomes 0. So here is the answer. So one thing you keep in mind, let us not do all this simplification. You are good at memorizing things. So you can memorize it, that is in plus in minus 2. It is nothing, very easy, just answer will be 1 divided by average of these two. Who is the middle number of these two? Let us go for the middle number. So that is n minus 1. If n value was 100, then it will be I 100 plus I 98. What would be the final answer? 1 by 99. Is there any simplification required? Not at all. Let us go for the easy part. So hope you got the solution given to the third and fourth. Let us come to the fifth one. Here, integral half to 1 by root 2. dx divided by x square into root of 1 minus x square. So how shall we integrate it? Is it any of the standard integral? No, it is not any of the standard integral. What shall we do? How to integrate it? Will it anything help us? See, in our first session, I think it was on 24th Saturday, 24th or 25th Saturday, that is first online session, we handled such questions. So I am considering only the integrand from this. There is x square. Is it not lying in the fractional power half? Root means it is raised to the power half. 1 minus x square. Do you think if you substitute this function as t, its derivative is not present here, that is helpless. So do you remember the other concept, taking the highest degree of x outside? That is what you have to do. You have to keep x square outside. So how does it get simplified? Already there is x square in the denominator. Then when x square is kept outside, it will be x square raised to half, because that is raised to half. And inside the root, what is there, or inside the fractional function, when I take x square outside, this will be 1 by x square, first term. The second term would be 1. So it is cancelled, it is 1 by x cube. So 1 by x cube into 1 by x square minus 1, that is the function simplified to. So let us evaluate it. So the integrated part, what is the substitution we are doing? This part is to be substituted, that inside the fractional power. When you substitute 1 by x square minus 1 equal to t, on differentiating this is considered as x power minus 2. Use the differentiation formula, it will be minus 2 x power minus 3, which can be written as by x cube. And derivative of 1 is 0, so much dx will be equal to dt. So when you substitute it in terms of t, it will be integral. There is dt divided by dx by x cube. In the question you can find dx by x cube, that is nothing but dt divided by minus 2. And left out term will be the fractional term, that is t to the power of half, which can be written as root of t. Then let us evaluate the fractional power also. Let us consider the integral. Minus sign will be there, 1 by 2 root t. It is in the ready-made formula, it will be root of t plus c. Now from where to where? As we have not changed the limit, let us rewrite it as root of, what is the substitution? 1 by x square minus 1. From where to where was it? 1 by 2 to 1 by root 2. So substitute the upper limit. When you substitute x as the upper limit, 1 divided by 1 by root 2 square is 1 by 2. What is reciprocal of 1 by 2? It is 2. 2 minus 1. So that is the first term. And minus, give the value of x is equal to half. When you give x value as half square will be 1 by 4. Reciprocal of 1 by 4 will be 4. 4 minus 1, it simplifies to 3. So the answer changes to, this is root of 1, opening the bracket, it will be root 3 minus 1. And let us see the options, whether there is a option root 3 minus 1. Yes, C option gives the answer root 3 minus 1. So next is, interesting question it is. Similarly, there is one more question, you will have to handle it. Here is the integral 0 to pi by 2 square root of 1 minus sine 2x. Then how did we handle 1 minus sine 2x? See, it is lying inside the root sign. Derivative part is also not here. So let us try to get rid of the root sign. How can I get rid of that root sign? Here is root of 1 can be written as sine square x plus cos square x minus sine 2x is written as 2 sine x cos x. It is from the trigonometry. We use that. Won't it look like a square plus b square minus 2ab? Yes, we know a square plus b square minus 2ab is a minus b whole square. But while choosing the first function a, you should be very careful. Always you choose such a way that a is greater than b. Where to where is the limit x value? X value is lying from 0 to pi by 2. See, let us think about the graph of cosine function and sine function. See, from 0 to pi by 2. Let us assume here is pi by 2. The cosine graph goes like this. If it is 1, it will be crossing this. Whereas the sine graph will be going above. At pi by 2, it will be reaching 1. Where do they meet each other? They meet each other at pi by 4. See, this is graph of cos function, this is graph of sine function. Now, how to split this 0 to pi by 2? You will have to split it from 0 to pi by 4, as well as the other one will be pi by 4 to pi by 2. The reason is only so much. See this 0 to pi by 4, who is bigger, having bigger values? Cosine values are bigger than sine values. Then how to rewrite this function? This can be written as root of cos x minus sine x whole square dx. Whereas from pi by 4 to pi by 2, who are having bigger values? sine function is bigger than cosine function. So how do I rewrite a minus b? So that is written as sin x minus cos x whole square. Hope you got the content. See, only thing is when you are replacing inside the root function, if you are replacing it by a minus b whole square, a should be bigger than b value. That is the point to be noted. So if it is addition in between, no worries, no issues, added it will be positive, that's all. So here as it is positive inside, it cancels and the integration is only cos x minus sin x. And what about integral of cos x? It is sin x. So here on integrating it will be sin x minus integral of sin x will be again minus cos x, from where to where is it? 0 to pi by 4, plus now here we have integral of sine function. What is integral of? Because root and square is already cancelled, and integration of sine function will be minus cos x minus cos x integration will be sin x. It is from pi by 4 up to pi by 2. So we need to substitute the limit. You know, upper limit cos pi sin pi by 4 is 1 by root 2 plus cos pi by 4 is 1 by root 2. 1 by root 2 plus 1 by root 2. 2 divided by root 2. That is nothing but root 2. Then minus of, give x value as 0. Sin 0 it is 0. What is cos 0? 1. Its work is over. From the two functions I am keeping negative sign outside. So it is put outside. That I will write here, minus. Give the value of x is equal to pi by 2. When x is given pi by 2, cos pi by 2 is 0, sin pi by 2 is 1, minus, give the value of x is equal to pi by 4, 1 by root 2 plus 1 by root 2, which is 2 divided by root 2. So here 2 by root 2 will be root 2 minus 1, again minus 1, these two multiplied it will be positive, and this is root 2. So it is very clear, that is 2 times root 2 minus 1. Let us see the options, whether there is a option 2 times root 2 minus 1. It is found in option D. So we got the answer to these. It is 6 questions. So let us go to the 7th one. So it is almost same fact. Inside the root side, don't you find 1 plus sin x by 2? This is one of the questions appeared in 2025 CET, and the previous was from the exemplar question. You know exemplar book, hope you are solving such kind of books, it helps you a lot. Then how to rewrite this one? We are able to write it as sin square x by 4 plus cos square x by 4. If you were inside the classroom, I would have waited for you to simplify. So this 2 sin x by 2 can be written as 2 sin x by 4 cos x by 4. So this is all about 1 plus sin x by 2. Then as it is a plus b whole square, nothing about bigger or smaller. It is only when a minus b appears inside the root. So here no issues, no need of breaking it. It is sin x by 4 plus cos x by 4 whole square, because the integrand was root of this function. After cancellation it will be sin x by 4 plus cos x by 4. So we need to integrate this function. Let us integrate sin x by 4 plus cos x by 4. The first term simplifies to minus cos x by 4 divided by 1 by 4 is equivalent to multiplying by 4. The next term, cosine integration will be sin x by 4 divided by 1 by 4 is equivalent to multiplying by 4. So we will keep that 4 outside and substitute the limit. Limit is from 0 to pi by 2. So when it is kept outside, 4 kept outside, here the first term will be sin x is given the upper limit 2 pi divided by this 4 is there minus cos x is replaced by upper limit 2 pi, then divided by 4 as it is minus of lower limit was 0, give the value of x as 0, sin 0 will be 0 minus cos 0 by 4. So on simplifying, we get the answer. We know sin pi by 2. What is sin pi by 2? It is 1. And cos pi by 2 is 0, that is vanished. Sin 0 is 0. Negative and this negative multiplied, it will be positive. Cos 0, it is 1. So 1 plus 1, 2 into 4, answers is 8. So there is a option 8, it is option D option. Here is the greatest integer function. When discussing the synopsis, I came across this. See, inside greatest integer, there is no x, but it is 3x. So who varies from 2 to 1? Our x vary from 1 to 2. Lower limit is 1 and the upper limit is 2. But now we will have to think the function 3x, because inside greatest integer there is 3x. All that you have to do is multiply 3 to the inequality. So the first term is 3 less than or equal to 6. Now you have to think which are the integer values. So the integer values, that is when 3x equal to 4. 3 is the integer value and the next integer value is 4 between 3 and 6. When 3x is equal to 4, what is our x value? It is 4 by 3. Which is the next integer value? It is 5. What will be the x value? It is 5 by 3. And which is the next integer value? It is 6. When 3x equal to 6, what is the x value? X value is 2. If I didn't write the term in the beginning, if 3x equal to 3, you know x equal to 1. Is our x lying from 1 to 2? Yes. So we have to rewrite this question. Integral 1 to 2 is split into these many functions, for which x value make this function a integer. That is x equal to 4 by 3, from 1 up to 4 by 3. When x is given 4 by 3, this will be an integer, 3x will be the integer. That is the first set. And then from 4 by 3 to where should you go? It is up to 5 by 3. Is it not x varying up to 5 by 3? And then plus from 5 by 3 to where you have to reach? Up to 2. Then next let us decide the integrand. For values lying between 1, x values lying between 1 and 4 by 3, what about our 3x? It is lying between 3x will be lying between 3 and 4. When 3x is given the value 1, this is 3, and x is given the value 4 by 3, 3 cancel, it is 4. So what is greatest integer of values lying from 3 to 4? It is 3. So in the same way, give x value is the lower limit 4 by 3. When x is 4 by 3, 3x will be equal to 4. When x is 5 by 3, 3 cancel, upper limit will be 5. So the greatest integer function has values from 4 to 5. What is greatest integer of values lying from 4 to 5? It is 4. So it is 4 dx. So you know the next one, it will be 5 dx. Is it not 5? Yeah, it will be from 5 to 6. Yeah, now you need to integrate. Integration of 3, it is 3x from where to where? 1 to 4 by 3, and the next will be 4x from 4 by 3 to 5 by 3, and the next is 5x from 5 by 3 to 2. So we need to substitute it 3 into upper limit minus lower limit, give 4 by 3 minus 1. What about 4 by 3 minus 1? It is 1 by 3 plus 4 times. Give x as the upper limit 5 by 3 minus x as the lower limit 4 by 3. 5 by 3 minus 4 by 3 will be 1 by 3 plus 5 into. Similarly, when you simplify it, it will be again 1 by 3 because 2 minus 5 by 3. That is 6 minus 5 divided by 3. How many times 1 by 3? 5 plus 4, 9, 9 plus 3, 12 times 1 by 3. So 12 times 1 by 3 will be equal to 4. So therefore the right option to that is B. Hope you understood how to how to handle this function, greatest integer function. Yes. Next is, okay, here it has come in 2 different pages. It is okay, we will manage. See, here is the function. X value lie between 0 and 2 variable, and the function inside the greatest integer is x square. See, our x value, it lie between 0 to 2. About whom should we think? X square. So x square, just square it. Are they not positive values? We can directly square it. When it is, there is a negative value, we'll have to be cautious. So 0, when squared, its square will be from 0 to 4. So square of these values will be from 0 to 4. Now that you have to think is, when do x square become very next integer? That is 1. So for these values lying here, that is x is equal to 1, this x square will be 1. We need our x values from 0 to 2. Which is the next integer? Next integer is 2. So which kind of x value does it become 2? It is for x is equal to root 2. Then the next integer is x square is equal to 3. That implies x is equal to root 3. And one more, x square is equal to 4. We know x is equal to 2. The work is over. Breaking is over. Hope you understood how to handle a greatest integer function. So if you are in the class, I could have seen your face and identified your response, what extent you understand me or not. So the first integration is from 0 to 1. And the next integration is from 1 to root 2, and another integration is from root 2 to root 3, and one more integration from root 3 to 2. Got it? So for values lying between 0 and 1, what about the x square values? That is also from 0 to 1 itself. Its greatest integer value is 0. So values, x values lying between 0 and root 2, x square will be lying from 1 to 2, its greatest integer will be 1. For the values of x from root 2 to root 3, x value is from root 2 to root 3, so x square value will be from 2 to 3, greatest integer is 2. For values from root 3 to 2, what about the x square value? 3 to 4. 3 to 4, greatest integer is 3. So you know to integrate this function. Here integral of 0 is 0, nothing to worry here. Here it is, integration is x. So upper limit minus lower limit plus 2x upper limit minus lower limit. The next is 3x on integrating upper limit minus lower limit. So here complete integer 3 into 2 6 minus 1, that is 5. So this is considered, this is also considered. Next is root 2 term. Here it is 1 root 2 minus 2 root 2. So totally minus root 2. Then root 3 term, that is minus 3 root 3 plus 2 root 3. So it will be minus root 3. Is there an option 5 minus root 2 minus root 3? It is option B. So the next one, yeah, here is the question. See, you are given integral 0 to k, dx divided by 2 plus 8x square. Answer they have given. You have to find out the upper limit. Just integrate it. We have studied in our previous session, I mean last Saturday. What is the formula suitable here? The suitable formula for integrating that function will be 1 by a. What is a? Root 2 square. So this is of the form 1 divided by a square plus x square. So a value will be root 2. 1 by root 2 tan inverse of x. So what is actually squared? It is 2 root 2 whole square. 2 root 2 x. Root of 8 is 2 root 2 into x whole square. X divided by a is root 2. But be very careful. x has a coefficient 2 root 2. So we have to divide by 2 root 2. Integral should be divided by 2 root 2. So this simplifies to 1 by 4. Tan inverse of, here it is cancelled. Let us give the limit 0 and upper limit is k. So the first term will be tan inverse of 2k minus, give the value of x equal to 0. Tan inverse of 0 will be 0. What is the answer given to you? It is pi by 16. We can cancel this 4 times. So what do you get from this? Tan inverse of 2k, it is simplified to pi by 4. For which value the angle will be pi by 4? It is for 1. So who become 1? 2k equal to 1. If 2k is equal to 1, what will be the k value? K value will be half. It's completed. Yeah. Here is the next one. Now we need the help of inverse trigonometry. See, I'll give you the inverse trigonometry list. Cot inverse of x or cot inverse of 1 by x. When do that become tan inverse of x? This is only when x is greater than 0. But there are x values negative as well as positive. So let us think about what will be cot inverse of 1 by x when x is negative. When x is negative, this is nothing but tan inverse of x minus pi. This is the case when x is less than 0. So one of the information needed is that. So how do I rewrite this integral? See, x varies from minus 2 to 1. Let us split it as minus 2 to 0 and the other part is 0 to 1. So the second part is 0 to 1. Now here, when it is negative, what about our tan inverse of x? Tan inverse of x has no change. Then cot inverse of minus x. What is the answer of cot inverse of minus x? It is tan inverse of x minus pi. So that is the first function. And the second function, these are positive values of x. So the first function does not change. It is tan inverse of x, and the second function cot inverse of 1 by x will be also considered as tan inverse of x. So much dx. So here we have 2 tan inverse of x. Here also there is 2 tan inverse of x. That 2 tan inverse of x is from minus 2 to 0 as well as 0 to 1. Shall I consider it as minus 2 to 1? 2 tan inverse of x. Then the extra part here is minus pi. There it is over, and integral of minus pi, from where to where is it? Minus 2 to 0. Now we need to integrate. It is not a ready-made answer. So it is better you remember the answer as x tan inverse of x minus 1 by 2 log of 1 plus x square. If I told you to memorize those part in the classes while doing the classes, so I hope Panchajanya students may remember the answer, ready-made answer. So we will have to integrate for those students who forgot that, or those students who haven't come across that. Every teacher might have told you how to integrate just indefinite integral tan inverse of x. It is into 1 dx. By parts we will have to follow. So it is first function tan inverse of x into integral of 1, that is x, minus integral of 1 is x, and derivative of tan inverse of x is 1 by 1 plus x square dx. So the first function remains same, x tan inverse of x minus, this is followed by substitution. On substitution this simplifies to half into log of 1 plus x square. Here no modulus sign is needed because 1 plus x square is ever positive. So hope you know the substitution to be made is 1 plus x square equal to t. So we will take it this side. We will consider that answer. Say the first term will be 2 times. Here integrated answer of tan inverse of x. Tan inverse of x is x into tan inverse of x minus half log of 1 plus x square. From where to where is it? Minus 2 to 1. Minus 2 to 1. minus integral of pi, it is pi into x, it is from minus 2 to 0. So, let us give the upper limit, 2 remains 2 outside. When given x is equal to 1, 1 into tan inverse of 1, it is pi by 4 minus 1 by 2. Given x is equal to 1, log 2, keep it as it is, minus of, give x is equal to minus 2. So, this will be minus 2, tan inverse of minus 2 will be minus tan inverse of 2. Hope you understood how negative became positive. Then this minus sign minus 1 by 2 into, give the x value is minus 2, minus 2 square is 4, 4 plus 1 5, it will be log of 5. So, that it is closed, and minus pi times, give the upper limit for x, it is 0, minus, give the x value as lower limit, once again minus 2. So, now let us simplify that. On opening the bracket, 2 times pi by 4 is pi by 2. On opening the bracket, half and 2 gets cancelled, it will be minus log 2. And the next term, negative sign, 2 into this 2, it is 4, tan inverse of 2. Once again, negative into this negative, it will be positive. 2 multiplied to this 1 by 2, cancelled, left with log 5. And the last term is minus 2 pi. So, here this will bring the log terms together. This is log m minus log n. This is log m by n minus 4 tan inverse of 2. Then pi by 2 minus 2 pai, which simplifies to minus 3 pi by 2. Is there an option accordingly? Let us try it. So, yeah, here is the option. Log of 5 by 2 was positive, minus 3 by 2, minus 4 tan inverse of 2. Is it that? Log of 5 by 2, minus 4 tan inverse of 2, minus 3 pi by 2. So, the option is right, option is option B. So, till here I was just handling integration, direct integration, limit substitution. Now, from question number 12 to the rest of the question, some sort of property is applied. Let us evaluate it. Here is the question, integral 0 to pi by 2. Let us think about our queen. Before queen, we will have to simplify log of a plus b sin x minus log of a plus b cos x. So, this is what the integrand is simplified using property of log. Now, give the variable as upper limit minus x using Queen's property. How can I rewrite it? Log of a plus b into sin pi by 2 minus x will be cos x minus log of a plus b into, what about here is the variable x, pi by 2 minus x, sin pi by 2 cos pi by 2 minus x is sin x. So, so much dx. So, here it will be 0 to pi by 2. Let us add the two functions. If I am naming it as I, then two functions added 2i. 2i equal to, on adding in the integrand, is it not this function positive and opposite in sign here? Does it cancel with this? So, what is there for integration? 0 dx. What is the integral of 0? It is 0. So, I is equal to 0. Otherwise, you understand, is it a odd function? You replace x by minus x. Will it be negative of the given function? This will be a plus minus b sin x, but that is not easy to analyze. No, let us, we anyhow got the answer. So, let us go for this. Here option is option A. Yeah, here is the next one. See, f and g are continuous functions in the interval 0 to 1, satisfying f of x satisfy this and g of x satisfy this equation. You need to integrate 0 to a f of x into g of x dx. Let us work it out. Here it is 0 to a. What shall I write f of x? Let me use Queen's property. Using Queen's property, it can be written as f of a minus x into g of x replaced by a minus x. So much dx. Then what about our f of a minus x? It is equal to f of x. Let me name the integral as I. So this first function will be f of x. And g of a minus x. What is g of a minus x from this equation? It is a minus g of x. You are shifting it to the other side. So much dx. Let us split into two different integrals, where the first integral is 0 to a f of x into a dx, whereas the second integral is 0 to a f of x into g of x dx. Is it not the second integral original I itself? It is I. So let me shift it to the left side. Minus I taken other side, it will be plus I. So added with that, it will be 2I. 2I will be 0 to a f of x. Is it not a complete constant I am taking outside dx. So the suitable answer I will be equal to a by 2. Bring this to the right side, you get this as the answer. Here is the next one. See here, lower limit is a minus x, upper limit is b minus x, and we have the function f of x plus 6. And the options are slightly changed with the lower limit a and the upper limit b. Where did that 6 go? What shall we do? Let us think about the substitution. X plus 6 equal to t. Immediately after substitution, we are differentiating it. 1 dx is equal to dt. We need to find out the lower limit, upper limit. Let us give x as a minus 6. What about t? A minus 6 plus this 6 equal to t. Is it cancelled and become a? So the lower limit has become a. Similarly, when you give the upper limit to x, you get it as b. And you are with f of, what is our x plus 6? It is t. And what is dx? Dx is dt. So use the very first property. When you change the variable, definite integral does not get changed. So which is the suitable answer? It will be a to b f of x dx. T is replaced by the variable x. This is one of the questions from your senior's question paper, that is 2026 CET question. So here is the next one. One of the possible functions f of x which satisfies minus 2 to 2 f of x dx equal to 0. Just observe the lower limit and upper limit. Are they opposite in sign? Yeah, what should come to your mind when the limits are opposite in sign? Is the integrand odd or even? Chances to be odd, because answer is 0, is it not? Which out of the 4 options are odd function? Is it an odd function? No. When you replace x by minus x, tan of minus x minus, again minus, it become even. This is neither even nor odd because of this constant 1. Then here we are unable to decide. You can't consider it 2 minus x, nothing to be decided. Then probably this. Let us replace x by minus x. So it will be 2 minus x divided by 2 plus x. Is it not equal to minus of log of the reciprocal? 2 plus x divided by 2 minus x. In logarithm chapter, you might have come across the property like this. Log of 1 by n. What is it equal to? Minus log n. When you reciprocate this, negative sign comes outside because it is log 1 minus log n. What is log 1? Log 1 is 0. So minus log n is the answer. That is all. When the reciprocal is made, there is a negative sign. So what happens? Minus f of x equal to f of x. This is an odd function. So only to odd functions the answer becomes 0. Not only here. Here the suitable answer is that. So So next, coming to the question 16. See, this is what I just forgot to mention while discussing the synopsis part. You have studied area function in two fundamental theorem of integral calculus, and the first fundamental theorem is like this: if a of x is the area function, then what about a dash of x? You can say that if a of x, how is a of x given by? Let us go for the area function. If it is a of x equal to integral 0 to x f of t dt or f of x dx, anything f of t dt, then what will be a dash of x? A dash of x will be 0 to x, not 0 to x, it will be just f of variable t should be replaced by the upper limit. So it is f of x into derivative of x will be 1 minus variable t should be replaced by lower limit into derivative, that is not needed. This much is given in your NCERT. So a dash of x will be f of x. There is extra version for this. If you are given a of x as integral of the function f of x dx may be from phi of x to xi of x. If this is the case, then a dash of x will be f of, replace x by upper function xi of x into its derivative xi dash of x minus replace x by the function phi of x, then into its derivative phi dash of x. So this is Leibniz rule. So for integration, now let us apply that here. F of x instead of a of x, they mentioned it as f of x, and f of t is cos of t cube dt. We need to find f dash of x, and let us find out f dash of x. What will be f dash? The same function, replace the variable t by sine. So it will be cos of sine cube x into derivative of the upper limit, that will be cos x, minus replace the variable t by lower limit, that will be cos of 2x whole cube. 2x whole cube is 8x cube into derivative of the lower limit is 2. Is there an option accordingly? Cos of sine cube x into cos x minus 2 times cos of 8x cube. It is option A. We are using this part. Hope you understood this. Next is the 17th question. Yeah, the same fact is used. Yeah, here is the function f of x. Lower limit is 1, upper limit is x square, and the variable is t. So let us replace the, we need f dash of x. Let us find f dash of x. In the integrand, replace t by upper limit. So root of x square. What is root of x square? X. Because here it is t greater than 0. So positive values of x is considered into derivative of x square. What is derivative of x square? 2x minus replace t by the lower limit, that is tan inverse of root of 1 is 1 into derivative of 1 is 0. So we need f dash of 1. So f dash of 1 will be x replaced by 1, tan inverse of 1 is pi by 4 into 2 into 1, and here anyhow it is 0 into any number, it is 0. This simplifies to pi by 2. See, here is the option pi by 2. So next we need to go to the 18th one. Yeah, here is the 18th question. There f of x was given, but here x is given and the upper limit is y. We need to find d square y by dx square. Let us differentiate with respect to x. On differentiating with respect to the variable x, left side on differentiating is 1, derivative of x with respect to x is 1. Using area function, how can I rewrite it? Replace the variable by upper limit. Is it not 1 divided by root of 1 plus 9y square into derivative of y with respect to x, that is dy by dx, minus replace the lower limit by t by lower limit. So, it will be 1 by root of 1 into derivative of 0 is 0. So, the second term vanish. Now, we can bring this side. What is dx by dy? Dx by dy will be 1 by root of 1 plus 9y square. Are you asked d square y by dx square? No, you are asked d square y by dx square, not d square x by dy square, d square y by. So, reciprocal we are finding. So, what is dy by dx? So, dy by dx will be root of, here it is gone, sorry. It will be root of 1 plus 9y square. Now, you need to differentiate this with respect to x once more. On differentiating this with respect to x, what happens? It will be d square y by dx square. So, root function derivative is 1 by 2 root of 1 plus 9y square into derivative of 1 plus 9y square, it is 18y, derivative of 1 0, 9y square is 18y into dy by dx. Is it not this cancelled? Yeah. Here numerator is 9y, denominator is root of 1 plus 9y square. What is our dy by dx? Dy by dx will be root of 1 plus 9y square. You can cancel it, answer will be 9y. Is there an option 9y? They have told you that second order derivative is ay. Then if 9y is equated to ay, what is a? A will be 9. That is all. Option C. So, the next question. Here is the question, that is minus pi to pi. Sin x raised to 4 divided by cos x to the power of 4 sin x to the power of 4. What did I say you? Lower limit and upper limit are opposite in sign. Check whether it is odd or even. When you replace x by minus x, are all the functions raised to even number? So, negativity vanish. It remains the same. You know to check it, check it. You get f of minus x will be equal to same f of x. What is the last property? That property says it is 2 times, but the lower limit becomes 0 to pi. Here it is sin x to the power of 4 divided by cos x to the power of 4 plus sin x to the power of 4 dx. Once again, you will have to go for Queen's property. When you substitute, or is it Queen's property applicable? No, it doesn't change to co-function. So, it is the last but one property, that is f of upper limit minus x, whether it is equal to f of x or minus f of x. That is a question to you. So, let us substitute sin of upper limit is pi. What is sin pi minus x? It is sin x. That raised to 4 it will be sin x to the power of 4. Then second term in the denominator also will be sin x to the power of 4. Now think about cos pi minus x. What is cos pi minus x? Minus cos x. Minus cos x raised to 4, it remains cos x to the power of 4. So it will be cos x raised to 4. Is it not the original function itself? It is equal to f of x. If this is the case happen, what changes take place? It will be, already there is a constant 2, this integrand changes to 2 times integral 0 to half of the upper limit, that is pi by 2 into the same function, sin x to the power of 4 divided by cos x to the power of 4 plus sin x to the power of 4 dx. Now here you apply Queen's property. According to Queen's property, did I give you a shortcut formula? If the function appear in the form a to b f of x divided by f of a plus b minus x plus f of x, what is the answer? These two together multiplied, it is 4. So what happens? It is upper limit minus lower limit divided by 2. So this answer will be 4 is the constant multiplied, pi by 2 divided by 2, it will be pi by 4. Simplified answer will be pi, that is found in option D. Hope you understood which result is applied here. That is integral a to b f of x divided by f of x plus f of a plus b minus x dx. This is the property. So here it is b minus a divided by 2. Directly I have used that. So it saves time. Then next question number 20. Yeah. Now the only question is whether it is odd or even. Lower limit is minus a, upper limit is a. Let us think about f of x. What is our f of x? X into mod x. Find f of minus x. That x replaced by minus x into modulus of minus x. Then this is minus x. What is mod of minus x? Is it not equal to x itself? Mod x. Now are they opposite in sign? Yes. So we can say that f of minus x equal to minus f of x. So what happens here? The answer, it is equal to 0. Simple fact it is. But you should realize it is an odd function. That is the important thing. Once again we have lower limit is half, minus half, upper limit is half. They are opposite in sign. But what about our cos inverse of minus x? Going to our inverse trigonometric classes, is it equal to minus cos inverse of x? Never. It is pi minus cos inverse of x. Sorry, it is, pi minus cos inverse of x. Then it is not an odd function. But we can rewrite it minus half to half. There is an identity that cos inverse of x plus sin inverse of x is equal to pi by 2. So let us apply that. Here what can we do? Cos inverse of x can be written as pi by 2 minus sin inverse of x. Now my question is this an odd function? Yes, because what is sin inverse of minus x? It is equal to minus sin inverse of x. Is it not satisfied f of minus x equal to minus f of x? So obviously this is an odd function, its integral is 0. Second function answer is 0. Now you need to integrate pi by 2 dx. What about the integration? Pi by 2 into x. That x varying from minus half to plus half. So the answer will be pi by 2 into replace x by half minus replace x by minus half. So therefore it will be 1 half plus half 1 into pi by 2. The answer is C. So there are questions like this. Instead of cos inverse there will be cot inverse, or if there is tan inverse it is easy, it is an odd function. But when there is cot inverse, what you need to do? You have to write it as pi by 2 minus tan inverse of x. Here is the next one. Again lower limit and upper limit are opposite in sign. Then is it an odd function or an even function? Directly it is neither even nor odd. You just replace it and try it. So what I am going to do is I am going to split it. Splitting is like this: minus 1 to 1, x cube plus 1 divided by x square plus 2 into mod x plus 1 dx. One portion of it plus, again the limit will be same, mod x divided by x square plus 2 into modulus of x plus 1 dx. Sorry, here plus 1 I will have to choose it with this function. So here it is x cube and mod x plus 1. So now let us think what happens when I replace x by mod x. Sorry, x by minus x. X square and minus x square remains same, no change. Mod of minus x is also mod x. So denominator is unaltered by rewriting x as minus x. Now all we have is numerator. What is minus x whole cube? It is minus x cube. So what happens? It is an example for odd function. Answer is 0. Now we have only this. Whether we are able to simplify, that is all. It is not an odd function, neither an even function. So what we have to do is modulus of x plus 1 divided by mod x plus 1 whole square, because x square can also be written as modulus of x whole square. It is the same. So what happens? It will be mod x plus 1 whole square dx. Let us cancel it on cancellation. Now what happens here? We have, it is integral minus 1 to 1, because this is vanished, first part is vanished. Integral minus 1 to 1 divided by modulus of x plus 1 dx. Then how to integrate it? Here let us go for, that is, replace x by mod x. When you replace x by mod x, that is, if I choose f of x is equal to 1 divided by mod x plus 1. What is f of minus x? Is it not the same? 1 divided by modulus of minus x plus 1. Is it not 1 divided by mod x plus 1 itself? So f of minus x is equal to f of x. So this is an example for even function. As it is an example for even function, we can rewrite it like this: integral 0 to 1, rather than minus 1 to 1, it is 0 to 1, 2 times the same integral of 1 by mod x plus 1 dx. For values lying from 0 and 1, what is modulus of x? It is x itself. So it will be integral 0 to 1 divided by x plus 1 dx. On integrating, the answer will be log of x plus 1. Give the lower limit here. Upper limit 1. So that will be 2 times log 2 minus 2 times, give x equal to 0, log 1. Log 1 value is 0. So the answer will be 2 log 2. Is there an option 2 log 2? Yes. It is one of the options. It is option B, that is 2 log 2. So last few questions are remaining. Yeah, here is the other question. This fine afternoon, hope you are not sleeping. Here, does it look like integral a to b f of x divided by f of a plus b minus x plus f of x dx. Here f of x is sine cube x, same thing. What is f of a plus b? 0 plus pi by 2 minus x. Sine pi by 2 minus x will be cos x. When this is cubed, here also it is cubed. Is it not the same function? I have given you the answer. It is b minus a by 2. Upper limit minus lower limit divided by 2. It is pi divided by 4. So it is completed. So then next we have the 24th one. Yeah. Here is the question. 24th question. Same fact we are using. You can consider it a to b. 4052. Root of x. I am going to replace x by, or else let me write x itself here, root x. Is it not f of a plus b minus x? Yeah, 4052 minus x. The same fact. What is the answer? Answer will be 4052 minus 0 divided by 2. Is it not 2026? Yeah, 2026. That is the suitable answer to the 24th question. And next we have the last question, that is question number 25. Yeah, here is the one. Minus 2 to 0, x cube plus 3x square plus 3x plus 3 into so much. Just observe these many terms. Is it possible to write x plus 1 whole cube? What is actually x plus 1 whole cube? X cube plus 3x square plus 3x plus 1. So how do I rewrite this function? It is minus 2 to 0. Is it not x plus 1 whole cube? extra what is here? We have used only 1 out of 3. So, plus 2 is here, plus x plus 1 cos of x plus 1. This much dx. So, now we need to integrate this function. So, just to try it. Why not substitution x plus 1 equal to t? A number of times we come across x plus 1 equal to t. Is it not t cube plus 2 into plus t cos t? When you do the substitution x plus 1 equal to t, dx will be equal to dt. So, here variable is changed. Why not? We have to change the limits. When x equal to minus 2, t will be minus 1. When x equal to 0, t will be equal to 1. See the limits, they are opposite in sign. Is it possible to decide as odd or even function? We can't decide about this two. We can make a decision about these two. Those two together it is odd function. We will split that. On splitting that, we are able to write it. Let me continue it here. We are able to write it as integral minus 1 to 1 t cube plus t cos t dt plus integral minus 1 to 1 2 dt. As it is an odd function, answer is 0 plus integral of 2 dt will be 2 into t from minus 1 to 1. So, that it will be 2 into, replace t by the upper limit minus lower limit. So, therefore, here it will be 4. Is there an option 4? Yeah, this is the option. So, thank you for listening to this video. So, hope you understood this exercise or in a definite integral. We have put our effort in engaging you in these holidays, or we didn't give it as a holiday, we made you to work at home. Hope you focused on the studies, or hope for the next class to be offline in the classroom. Thank you.